time what I had is like the YouTube open with no audio and then just the audio from there. Which I don't mind doing that. Like, that's not the end of the world.
I'm gonna go ahead and try streaming in Discord and see if it works. Let me know if you can see.
If you don't mind. Let's have a look. Yeah, it seems to be working fine for now.
Perfect.
Right, here we go.
I can see your hub.
Alrighty, guys. Well, for those that are tuning in either on the stream on YouTube or those that are coming in after the fact, we're going to do some Unity tutorials here. I don't really have anything planned. We're just going to kind of go with the flow.
Let's go.
With me today, I have two oneleif members. I have Max and Stefano. Feel free to introduce yourselves, guys.
After you, mate. You first.
Hi, I'm Stefano. I'm an aspiring game dev, and I've got games I want to make.
Yeah, that's similar for me. I'm from the UK. My name's Max. I recently joined and looking to build some stuff, and games I've always been fascinated by. So I think it's a good place to explore.
Woo.
So as I was thinking about this, I literally sat down and started thinking about it like 20 minutes ago because I got home from Easter. I think we're going to make Snake today. How does that sound?
Oh, okay.
Dude, that sounds amazing.
Let's do it. I made a 3D Snake a while ago. I think I deleted it. But we'll make it.
I was like addicted to that as a kid, you know, on the Nokia 3210.
Yeah, man.
Do you guys want to do it in 3D or 2D?
I'm happy to do 2D, to be fair. Or what do you think's like going to be like more educational?
That's a really good question. So, like 3D and 2D have very similar concepts. I actually have done like very, very little 2D. I like 3D. And 3D mathematics kind of fits the way my brain works, I guess. I know it's not that way for everybody. So I don't know if it would be better to go 3D because I know it's technically harder, I guess.
Okay, yeah. I mean, maybe that's if we start doing 3D now, then we can get used to it or something. I don't know.
And then you can always turn your game like I'll show you guys. You can always turn your 3D game into 2D, right?
Okay.
Oh, okay, yeah, that's nice.
So so I have Unity Hub downloaded. I also have the latest version. Okay, probably not the latest, but 2019.3 of Unity. If you guys want to open up Unity and follow along, feel free.
Yeah, that's the one I got.
I will on GitHub. I'll post a link on the YouTube channel when I'm done of the code base, so that way, if you guys want to have the working code when we're done, you can pull it down from GitHub and look at it.
Oh, awesome! Thanks.
I did that for the C# stream as well for those that were there for that. It's in the description of the video. Okay, so we're gonna go ahead and we're gonna go to projects in Unity Hub. We're gonna hit the new button. We're gonna all right. We're gonna click 3D. We're just gonna name it Snake 3D. And I have a nice little folder structure that I like to use. I have in my documents. I have a coding folder. That's where I put all my projects. Okay, so we're gonna go ahead and create the project, and it'll open up Unity. Before we get to actually starting to make the game, I'll walk you guys through the UI. I know I did this with you, Stefano, but I'm going to reiterate and make sure it kind of sinks in.
Sure thing.
So Unity is somewhat of a resource hog. Like if we open up Task Manager here, we can see it's taken up about 400 megabytes of RAM and about 10% of my CPU. And my CPU is pretty crappy, so like if you have a decent processor, you'll be fine. I haven't upgraded my processor in like 6 years. I need to get a new one.
Oh, dude, this computer's like 10 years old.
Dude, Max will last forever, though.
I know. I'm quite impressed.
I do know that Unity has some UI bugs on Linux. So if you're using Unity on Linux, do be aware that there will be issues. Feel free to either ask them to me in the Discord or do some Googling. Most people have ran into probably the majority of issues by now. So while Unity's building here, it's basically creating the project, compiling scripts, generating an initial scene, and then resolving packages and dependencies that are inherent to a 3D project.
Cool.
Oh, it opened up on my other monitor. Bring that guy over. Aha, I knew I wasn't on the latest version. Okay, so if you go up to Window, Layouts, I'm going to go ahead and hit Default, so I'll have the same view that you guys do when you first load in.
Mm-hmm.
Okay, so just to give you guys a very brief overview. So down at the bottom, this pane down here, this will be your project pane. You'll see we have an assets folder, and inside that assets folder, we have a scenes folder. So I can either click on this scenes folder to open it, or I can double click here. And then you'll see we have this scene called sample scene, and you'll see up here in the top left, that's the name of the scene that we currently have open. And then we have this extra folder called packages. It's some default things that Unity imports for you, for example, like analytics, if you want to keep track of what people are doing in your game, in-app purchases, things like that. We're not going to worry about them, but I just want you guys to be aware. So, to make you understand what happens when we create a Unity project, we're actually going to go to this folder where I created the project and look at the folder structure, because I think it's kind of important. Snake 3D. Okay, so at the top level of your project, you're going to have this assets folder. And if I open up this assets folder, it's going to look oddly familiar to the assets folder that's in Unity itself. And it is an exact replica. However, Unity does hide these .meta files. And if we open them up, all Unity does is for every folder and script that you create, it's going to have these meta files that tells you the format version of the file. It has a unique ID to the file so that Unity can keep track of where it's at. It tells you whether it's a folder or a file, and then it tells you how it was imported and whatnot.
Okay.
So when you are dealing with Git and GitHub and source control, you'll see these meta files. You won't really have to look at them, but Unity does need them to be able to perform correctly.
Okay.
So if we go back up a level, you have the library, which is like generated files. If we go look in here, you can see, you have different caches, script assemblies, things like that. You won't really need to work with it. Like, you could literally delete this and reopen the project and it would work fine because it will regenerate those files. Same with the logs folder, and same with the temp folder. The packages folder is a manifest. Manifest meaning this is how it keeps track of all the packages that we have implemented. So if you were to open it up, you'd see it points to all the packages that we have default imported down here. And then the last folder that we have is project settings. And if we open this guy up, you'll have different asset files. So for example, if I go up to edit, project settings, it represents what you've set in the Unity editor here. And it saves that to a text file so that way the settings are stored when you build your game. Okay, so now we want to take a look at how scenes work. And you can basically think of a scene as a level in a video game, right? So if I were to open up the scene, you could see in the scene I have a main camera and I have a directional light. Those things should be somewhat intuitive as to how they work. You can see, the light has different beams pointing in the direction that it's pointing. And then our main camera, if you click on the camera, you'll see it highlights whatever object you have. You'll see it gives me a projection of what the camera looks like. So if I fly behind the camera, this is basically its viewport of what it's seeing. It's basically kind of like a pyramid tipped on its side. And in the bottom right, it'll give you a preview of what you're seeing. So if we go ahead and if we right click in our hierarchy, right? So the hierarchy keeps track of all of the objects in our scene. And objects in Unity, so in normal C#, an object is like the top level of what everything inherits from. Whereas in Unity, the top level of things that can be in a scene are a game object. So if I were to right click, I can put things in the scene, right? So let's go ahead and just put a 3D object. Let's put a plane, or which is just a 2D flat surface, and in this case it's white. And let's add some color to it so it's not so ugly. So what we're going to do is we're going to go into the assets folder, we're going to right click on it, we're going to hit create, we're going to create a folder, and we're going to create a folder called materials. And we're going to go ahead and right click in that folder, hit create, and we're going to go make a material, and we're just going to call it plane for now. And then we're going to go over here, we're going to change the albedo, which is basically its reflective color, and we'll just change that to red. And then if we drag that material onto our plane, you can see the plane turns red. And as a side note, planes are one-sided, right? Just like in mathematics, if I go to the bottom of the plane, you can't see it at all. So now if I take this plane, so whenever you click on an object, depending on what selection method you have set up in the top left, you can see in this case I have arrows that if I click and drag them, I can move the object in its independent axes. And then in the top right, you'll see the axes that Unity has mapped. In this case, Y is up and down, Z is forward and back, and X is right and left. So what I want to do is just kind of put this plane out here and rotate it. And then I want to show you that the camera does in fact update and show you that preview. And if I go to the game view, right? So the game view and the scene view are separate. The scene view is basically you're editing the level outside of the game being running, and the game view, is basically what you'll see when you're playing the game. It's going to pretend as though this game is running. So the majority of the work that you're going to be doing is in the scene view, and then when you're testing your game, you'll go into the game tab. For example, if I just hit the play button up here, the game will start running. It'll pretend as though you are like running the game in Steam or something, and you'll see it automatically flips over to the game view. Right now we just have this flat plane and a camera looking at it. I can press keys and it's not going to do anything because we haven't set anything up, right?
Yep.
Okay, so the last little bit of interface that you need to know about is over here on the right-hand side, you have the inspector. And inspector does exactly what it sounds like. It allows you to inspect a game object. So if I click on the main camera, you can see it's highlighted. Over here on the right-hand side, you can see the name of the game object is main camera. You can see that there are some components attached to this thing, or to this game object. And a component is basically a piece of behavior that allows you to add some sort of functionality to your game object. In this case, since we have a camera, we have the camera behavior, right? And you can see a camera has a background, it has a field of view that you can change, and some more complex things that we won't get into because you typically won't have to mess with the camera. They're set up pretty default. Whereas if I go look at my plane, you can see my plane will have a transform. All game objects have a transform, and the reason for that is because my object inherits from game object, it inherits the properties of a game object, and the inherent properties of a game object are that it has a transform component attached to it. And what a transform really means is that it is a wrapper that holds the position, the rotation, and the scale of your object in 3D, right? So if I were to click and drag this guy, you'd see its Z value is changing in the inspector, right? Same with the X value and the Y value. And you can see when I rotated it, right? When I first made the plane, the X rotation was 0. What I did is normally you have these arrows right here that are for translating the position of your plane. But if you change the tool that you're using up in the top left, if I were to click on the rotate tool, these use hotkeys. I like to use, I believe it's W for positioning, E for rotation, and you'll see it changes to this like sphere. If I were to drag on the red line, it would rotate it on the x-axis. If I drag on the blue line, it rotates on the z-axis, and if I grab on the green line, it rotates on the y-axis. And you can see that they correspond to the colors of the axes in the top right. But I just wanted it rotated 90 degrees, negative 90 degrees in the x so that the camera could see it, right? So the other things that an object has in 3D is it has to have some way of rendering something, right? And in most 3D game engines, the way of rendering things is by using what's called a mesh. And what a mesh is basically just a conglomeration of vertices that are mapped to triangles, right? So in this case, on a plane.
Whoa, wait.
Yeah, what's up?
That's I know what those words mean individually, but what is a mesh again? Sorry.
Here, well, I was getting to that. We're gonna open up Microsoft Paint.
Right.
So let's say, for example, we're gonna have our red plane, right? Our red plane is okay. Pardon my not perfectly square square. Okay, so this is our plane, right? Well, how does your computer know how to put this on your screen? Well, what's the simplest geometric object that we can think to be able to render? And the simplest 2D object that you can render is a triangle, right? So really what a plane is just triangles. And then what you do to those triangles is you apply a material to each one of them. In this case, it'd be red, right? So you'd fill in this triangle with red, right? And then it would do the same for the other one.
Yeah.
So every object that you see in 3D is actually made up of triangles, but if it's a sphere, for example, it's just a bunch of really small triangles, right? So if we go back into Unity and we create a 3D object, let's make a sphere, right? And if we go to the mesh filter, you can see the mesh that it's trying to render, right? And if I double click on it, it'll open it in the bottom right, and I can make it really big, and you can see this sphere is actually made up of a bunch of triangles.
Oh, okay.
And then all you do to color the sphere is figure out what you want to color each one of the triangles.
Fair enough.
And this is how it works in just about every game in 3D. It's also how it works. It works in 2D. In this case, if we were to want to do Snake in 2D, we could just instead of having a cube, we could have instead of having a sphere, we could have a cube, and we could have this cube just move up, down, left, and right. And if we look from the camera, if we were to make these things, directly in front of the camera, let's say we make the plane, let's take a scale and make it 10 into X and Z, so now it looks like a flat surface. And then we take our cube, and if I were to just move it around, it kind of looks like it's in 2D, right? Because it's just the way that the camera is looking at it, right?
Yep.
But if I were to take the camera and change the way that it is projecting, right, from perspective to orthographic, it'll actually turn into 2D, which is crazy.
Oh. Huh.
And now if
Sorry,
we go back, you're fine.
Yeah, no, I'm just because I only have one screen, so I keep jumping from one to the other. So I'm
Gotcha.
just kind of.
And if we go back to our camera, you can see the orthographic projection instead of the perspective projection. Instead of it being a looking out, right? You can see our pyramid is kind of looking outwards. If we change it to orthographic, it instead projects from the back to the front, so it makes a flat surface, right? So it pretends as though it's 2D. And it's just some 3D mathematics to basically take 3D dimensions and project them down to, like, let's say you're looking at a sphere in real life, and the shadow of it is projected down onto a piece of paper, right? It's similar mathematics to how that would work. Okay, so if I'm thinking about how we're gonna do the snake game, what components or what pieces would go into a 3D snake game? I'm imagining as I play it, I move my mouse to look up, down, left, right, and maybe I don't need to press any keys. Maybe maybe me as a player is just moving forward constantly, right? And then it just depends on what direction I'm looking at. And if I hit something, I it disappears and then a new one spawns. Like the regular food and snake, right?
Yeah.
So let's kind of make, if in normal Snake it would just be a 2D plane, but since we're in 3D, let's make a 3D box that we're kind of stuck inside of. Does that make sense?
Ooh, okay. Yeah.
So let's take this guy and let's move him down to, a plane by default is 10 units by 10 units. So if I take its scale to 2 and 2, it's actually 20 by 20, right? And then
Okay.
I'm scaling it on the X and the Z axis. If I scale it on the Y, it doesn't matter, right? Because the plane is infinitely thin, right? So if I change this Y value, it doesn't change anything at all. Okay, so let's make it let's make it 40 by 40. And let's I feel like this material is a little bit reflective. It's kind of blinding. So if we go into our material for our plane, we can take the smoothness and we can drop it down so it looks more flat and not as reflective. And smoothness is a property of a material, right? Like if we up to the metallic, it would look more shiny. Well, it has to have some smoothness to look shiny, but if we take the metallic and smoothness to 0, basically like the surface is very rough and not metallic, right? So it's coarse. Like if you were thinking of like looking at a rock, for example, right? I just don't want it to be reflective, so that way it kind of throws the player off. Okay, so now we need to take this plane, and we want to basically make a cube out of it, right? So if it's 40 by 40, we want it to be, we'll put it at 0, 0, 0 for now, and then basically we want to move it 20 units away in the z-axis, and then we want to duplicate him, and the way we do that is we just click on the object that we want to duplicate, we hit Control-C, and then we hit Control-V, and now if I move it, you'll see there's a duplicate of it. And we'll put this guy at -20. And I don't like dealing with the rotations of planes, so we're actually going to cheat here, and we're just going to make them really thin cubes, right? So if we make this guy 40, 40, 0.1, and 4, so there we go. Okay, so now it's the plane was rotated, right? So we tried to modify the depth, which we thought was y, but since it was rotated, it was actually the z depth, right? Because like if we rotate it 90 degrees this way, the scale still stays the same, right? If we wanted to get the same exact, if we wanted it to look the same, we could just change this to 0.1 and this to wrong one. This to 0.1 and this to 40 and 40, right? Because we rotated on the y, so now the x-axis is flipped 90 degrees. Does that make sense?
Yeah.
Okay, cool. So we're going to go ahead and apply our material back to it. We're going to reset our rotation to make it simple. Make this guy 40, 40 and 0.1. So now it resembles a plane, right? You can see it actually has some thickness to it if I go look at the sides.
Okay.
And you can also tell which object I have currently selected by the current tool and the orange highlight around it.
Yeah.
Okay, so now let's move this guy to 0, 0, 0, and then we actually want him to be 20 over here, and we want to duplicate him and put the other guy at -20. And now we need to put a roof on it, so we will copy this guy, and we'll move him back to 0, and we want to move him up to 20 so that he's level. And then if we rotate him 90 degrees this way, now we have a roof, right? And then if we duplicate this guy and move him down to -20, we're starting to get this box feel. Now we want to take this wall and we want to move him not to -20 in the Z, but -20 in the X, and then rotate him in the Y-axis by 90. So now we have this face. And then we want to duplicate him and put him on the other side, right? So we copy paste and we move him to 20 on the X. And now you can see we're inside of this cube, right?
Okay.
And now over here on the left-hand side, you can see we have the 6 cubes resembling our walls, and the 1 cube that we created at the beginning, which is going to pretend to be our food that we're going to eat as a snake, right?
Okay, yeah. But the light source is still coming from the outside then?
So that's okay. So lighting is really complicated, right? So you can see our light source is technically in the middle, right?
Yeah.
So if
Or
I
is
were,
it? Sorry.
you're fine. So depending on the material that you're using, some materials can pretend as though you don't need a light in the scene. They can just have ambient lighting, it's called, right? Like it's pretending like all the light's coming from the sun. That's it. There's not technically a sun, but like the light on the material is calculated that way, right?
Yeah.
So everything in computer or in game development is kind of faked, right? There's not actually a sun casting light on everything because that would be really expensive, right? So really, like what you do is on this face, you'd break it into its triangle, and then for each pixel that you're going to render on the triangle, you'd calculate, okay, which direction is the light coming from? Okay, let's multiply my color by the intensity of the light on my pixel, right?
Okay.
I know that may be a little bit too complicated to start, but we'll get there in the future.
Yeah.
Okay, so you can see that let's pause here for just a second and see what our walls have, right? Our walls have a transform, and we've set those transforms to be able to make them a perfect box. We have a mesh filter, and the mesh filter is what holds the mesh that we're going to render. We have the mesh renderer, which holds the way that we're going to render this mesh. And in the materials, you can see our plain material that we created. That's gonna tell it how to render. And then we have a box collider. And if we click on the box collider, maybe not well. Okay, so if we just change the size of the box collider, let's make it like 1.2. You can see how there's this jutting edge over here, and it's green, right? Green represents what a collider is, right? So I increased it on the x-axis so it didn't like snap to the box itself, right? So this, if we were to have another object that had a collider on it and it ran into this, the physics system of Unity would know that these two objects have collided, and you can code it to respond how you want it to respond.
Okay.
So we're going to go ahead and set the collider back to 1. And if we zoom in really close here, you can see there's actually the green edge on the cube itself. Like basically the collider represents what the actual wall is itself.
Yeah.
Okay, so let's. I feel like the red is a little disorienting. Let's make each wall a different color so that way you kind of know which way you're facing, maybe.
Okay.
So let's go create some more materials, and we're going to keep it really simple. We're not going to think outside the box for material colors. I'm just going to call them. I'm going to rename them. So this guy is going to be. If you slowly double click, you can rename things. So we'll call this guy red. We'll call this guy green. We'll click on the albedo. We'll click on the circle and then move the opacity over. And then we can drag this green onto one of the walls. And then we'll make, I don't know, a blue and a yellow. And we'll continue to do the same process. Notice how I called this guy blue, but I haven't set his color yet. I dragged him onto this material, and then when I change the color of the blue material itself, it'll actually change all objects that have that material attached to it.
Okay.
And then, I don't know, we'll make an orange. And now the top and bottom can be the same color. I just want each wall to have a different color so it so you can kind of tell which direction you're facing. Okay, so our camera, so if we were to play like a first-person game, right, you kind of think of the camera as the player, right?
Yeah.
But usually the player would have like some sort of body attached to it and maybe some animation showing that you're walking or something. But since our game is going to be in first person and we don't have any other we're not playing multiplayer, right? So we don't really need to have a body because we're not going to see ourselves, right? We're just going to kind of be like this floating thing in the air. So
Yeah.
we're actually not going to add any body to our player. He's just going to be this floating camera. And you can see I have this like little camera gizmo. If I go into gizmos and I just toggle them off, you won't have them anymore. You can just see the floating point of where this object is.
Okay.
Okay, so what are we going to do? How do we make this guy move? Well, there isn't really any built-in way to make them move, so we need to make a script that will tell it how to behave, right? So this is where things get a little complicated, and this is where programming starts coming into play. So if we go to our assets folder, we're going to make a new folder called scripts, because this is where I like to, I have my own little organization that I've come up with. A lot of it is pretty common, like having a materials folder, a scenes folder, and a scripts folder is really, really common.
Yeah.
Also take note, I've been doing this out of habit, but if I were to just like slightly move this plane, in the top left, you'll see this little star or asterisk next to my scene name. That means the scene is unsaved. If I hit Control S to save, you'll see that star goes away. Okay, so we want to make our player move, right? So let's create a C# script, and we're going to call it player movement. And the way that scripts work is now that it's created, right? So if we double click on this script, it'll open it up in whatever the default editor is for your Unity. When you install Unity, more often than not, it'll come with Visual Studio. If it doesn't, and
Yeah.
you install Visual Studio separately, you can go to Edit or I haven't done this in forever. Project Settings, Editor. It's like External Editor. I don't remember where it's at. If somebody struggles with this, just message me. I can Google it for you. It's some property called External Editor, and you can set it to whatever you want. You could even use like Notepad if you wanted. Okay, so I went ahead and created my script. If I go ahead and open up the folder structure over here, you can see that Visual Studio is smart enough to only pick up on the C# scripts, right? It doesn't pick up on my scene, it doesn't pick up on my materials, because we're not going to be coding those things, right? Those are going to be handled for us in Unity itself.
Can we code them like later if we want, or
so
the script is only for the object, right?
So like we could have a script that would create a material at runtime, but we wouldn't like there isn't code behind a material, right? It's more like a set of settings, for example.
Okay.
So what comes in a script, right? I'm gonna clean this up a little bit and make it a little bit simpler. Okay, so in C# you use the word using to import, right? And in this case we're importing the Unity engine, which allows us to have access to several things under the hood. So when we went ahead and created our player movement script, it created a class called player movement, and that player movement class inherits from mono behavior. And if you click on anything in Visual Studio, like a method, a function, or whatnot, and you hit F12, it will take you to where it's defined. So you can see this is the mono behavior inside of the Unity engine namespace. You can see what comes with a mono behavior. A mono behavior has a constructor. It has some fields called whether or not it should run in edit mode, use GUI layout, and so on. It has all these extra things. Well, the only ones we really care about for now are start and update. And you can think of these similar to like how if you were just to run a basic like C# console script, start would be like the first line that is executed when the program is ran. Or in Unity's case, start happens when your object is enabled, right? If we were to go back to Unity, you'll see all objects, like if we click on our little food here, in the top right in the inspector, you see this checkbox? If I uncheck it, oh look, it's no longer there. It's disabled, right? Which basically just means don't render it in the scene and don't have any of its components do any of their functionality. Well, the start method can either happen when the scene loads up or when something is enabled for the first time. The update function, this function, whatever you put inside of here, is called every time Unity updates, right? So one of my favorite ways to show this off is if we just Google Unity, I believe it's life cycle, order of execution for function events. It's going to be this really long graph that kind of shows you the flow of how scripts work in Unity, right? So you have this awake function of like when the script is awake, when it's enabled, and then we have our start function, and then we have so on and so on. It gets even more complicated. But somewhere in here is update, for example, and this is where you'd put all like your game logic and whatnot. So if you're somewhat into Unity, I'd highly recommend checking this out because it'll make a lot of things make more sense. But
Yeah.
to keep it very simple, update happens once per frame, right? So if your game's running at 60 FPS or 60 frames per second, this update function will be called 60 times per second, right?
Yeah.
So
it's like,
go for it.
sorry. No, it's because I'm coming from Game Maker. I'm realizing a lot of the stuff is quite similar. It's just like different names. So like the void update thing is basically like the step function where every frame it checks for something, right?
I know absolutely nothing about Game Maker, so that sounds somewhat similar to me.
Yeah, so I guess it means like it's like every frame it's checking for whatever you put in there, as opposed to like the void start when it checks once when the thing is created.
Yeah. So just to let's make this point. Let's drive this point home. Built into Unity, right? If I just type in something in Visual Studio, Visual Studio imports the autocomplete from whatever packages you have. So you can see if I start typing debug, it comes from Unity Engine. And if it doesn't pop up when you click on it, you hit Control Space to make it re-pop up. Okay. If there's not more than one option, when you hit Control Space, it'll autocomplete for you. So if I restart typing and look at debug, over on the right-hand side, you can see debug comes from Unity Engine. And then we want to log is what we want to do. And all we're going to do is this is basically the equivalent to outputting to a console. We're just going to log the word start. And then we're going to log the word update, just to show you guys how this works. Okay, so now we have this script, and when it starts up, it should print out start. And every frame, it should print out the word update, right? So if I go ahead and hit run, everything should output to the console, right? Well, you can see nothing's outputting to the console. Well, we created the script, but we didn't do anything with it, right? It's just in our project. What we need to do is we need to add that script as a component to whatever game object we want. In this case, it's our player. And I'm actually going to create a new empty game object. And you can see it just comes out with a named game object, and all it comes with is a transform. We're going to right-click on transform and hit reset, and all that'll do is set its position to 0, set its rotation to 0, and set its scale to 1. So we just want it basically at the dead center, right? That's what transform reset did. And we're going to rename this object to player, so that way we can kind of keep things named correctly. And I'm going to create another empty object, and we're going to call this environment. And to clean up our scene, we're going to click, if we click on one thing and we shift click on something above, it'll select all the things in between it. And we're going to click and drag onto environment, and you'll see that now this thing is kind of parented to them, right? So now I can kind of collapse this and not have to see all those extra things in my scene, right? And we're actually going to delete this extra cube, which would have been our food. We'll get back to it later. So now our player, what does our player have? Well, let's drag the main camera under our player, because our player should have a main camera. And then now our player, what can we do with it? We can add our player movement script to it. So by going to our player movement script, clicking and dragging, and dropping it on here, we can see it attaches, right? If I right-click on it and hit remove component, it'll delete it. Instead of clicking and dragging, I could have went to add component, and we could have typed in player movement, and it would find it for us, right? If we go to add component and we don't type in anything, you can see all the different components that Unity comes with. It has things for physics that would include like colliders. It has things for meshes that would be like our mesh filter, our mesh renderer. You have things for UI. This would be like scroll views and things like that. It has a ton of default components for you. A lot of them you'll have to code for yourself, but it does come with quite a few that are useful. So now that our player movement is attached to a game object, right? It's in the scene, right? Like this start function would never be hit because it wasn't attached to anything in the scene, right? Because start basically says whatever game object we're attached to, we want to know when it is enabled and then start doing these things. Does that conceptually make sense of how this is working?
Yeah, definitely. I was just wondering if you apply a script to like environment now, the parent, will it update all the children as well?
No, so you can individually apply a script to each one of the objects themselves. So if I were to go to the environment and I click and drag player movement onto it, you can see if I click on its children, the player movement script is not in its components.
Oh, okay.
So we don't want our environment to invoke player movement. However, that might be something funny to show. But just to show you how this works, now that our player movement script is attached to our player, if we hit play and we go to the console, you'll see we're printing out start, and you can see on the right hand side it's printed out once. And then if we click on update, you'll see this number incrementing, right? Well, that's because that's how many times this has been printed. And it has this collapse button, right? And that's for basically saying if you're doing two of the same things in the update, collapse them into basically one debug log. If I hit the collapse button and uncheck it, you can see we're just constantly outputting update, right? Does that make sense?
Yeah,
Okay, cool. So
a little bit. It's
things might be a little hazy at first.
yeah.
Okay, so
Don't worry.
now we have this concept of we can do things when we start, and we can do things every frame. Okay, so step one, we want to make our player move. So what do we want to do? We can either make the player move first, or we can make the player look first. I'm going to start by just looking, because that is very easy. What we're going to need to do is we're going to need to basically rotate our player, right? So if I start the game, and now we're going to go to the game view, right? The cool part about Unity is, so one of the cool things about Unity is the UI is dynamic, so I can click and drag on this game view, and I can just snap it to the right side, right? So I can have my scene view that I can move around in, and I can have my game view that represents my player playing, right? Well, if I click on my player, and in the scene view, I rotate him, well, in the game, he actually rotates. Anything you do while the game is running doesn't save, but this will be a good way for you to be able to test what's going on, right? So basically all we want to do is we want to take this rotation, and when the mouse turns around, we want to turn the player in the correct direction, right? Does that conceptually make sense?
Yeah, definitely. Yeah.
Perfect.
Yep.
Okay, so what we're going to do is in the update function, every frame we want to see how much the mouse has moved, right? So what we're going to do is we're going to say input, and input is a function that comes from Unity. So if I hover over input, you can see it comes from Unity Engine, and it's the interface into the input system. And the input system is any input, right? A mouse, a keyboard, a game controller, any of those things, right? It even, the input system is becoming agnostic, so it'll even work for like Xbox, PS4, or Switch controllers. So in this case, we want to, oh look, it has the current mouse position, right? Or we can start looking at what all they have. So we could get a key, right? And it's based off of key code. So if we do key code dot, you can see we could access the A key, the escape key, the left control, and so on. But really what we want to do is we want to get axis. And this may not make sense, I'll explain it in just a second. And the axis that we want to get is mouse x. And what does this function return if we hover over it? It returns a float for how much we've changed. So we will call it x. I'll make this more descriptive. Mouse x movement. And then what we want to do is we want to say, we want to take the camera that we have and rotate it, or we can just take our game object itself and rotate it. So let's do that. So we can say game object dot transform dot rotation. I'll get back to this. We're gonna make it work first, and then I'll explain how it works. Okay. So we actually want to do dot y. We can't do that. I'll explain that in just a second. Okay, I just want to prove that this works, and then we can come back. Can be applied to quaternion. It is set Euler? Yeah. And this method is deprecated. Okay, so we're going to ignore this for now. There's a billion different ways to do things in Unity, and we're just going to do a simple way just so you guys can understand how it works. So now if we go back into the game and we move our mouse, it doesn't rotate because I did something wrong. Okay, so we'll go back and explain how this works, and then I'll tell you why it's not working. So get axis, right? Everything you do is technically an axis, right? So if I press the W key, it's basically an axis between -1 and 1, right? If I press the W key in, it'll give me 1. If I let go of it, it'll give me 0. If it were a joystick or an analog stick on a controller, if I were to go up and down, 1 would be the top and -1 would be the bottom. If I were to go to left to right, the x-axis would be 1 to -1, right? In this case, our mouse will be an axis, and looking to the left will be a negative, and looking to the right will be positive. If we go to Edit, I can never remember which one it is. Project settings, and then input. We can see the axes, right? And then we want mouse X. Oh, it's a capital mouse and a space between the X. So these are the default axes built into Unity. So like jump, for example, would be the space key. Fire 1 would be your left mouse button, or you can have alternative buttons. So for example, left control. Horizontal and vertical. So you'd have like the left and right arrow keys, or A and D, like if you're playing like a first-person shooter or something. And then vertical would be forward and back, so it'd be W and S, or up and down on the arrow keys. But in this case, we just want to use the X, right? Because this is the X-axis of the mouse. So if you're moving left and right with your mouse, right? And then mouse Y would be up and down with your mouse. But we're just going to do left and right for now to make sure this makes sense. So if we hit play, and we move our mouse to the left, I'm doing something horribly wrong. This function may not be working how I expect. Okay, so basically what we're doing here is we're getting whatever that the difference in the mouse x-axis is between this frame and last frame, and then we want to apply that to the game object that we're attached to. We want to get its transform and set its rotation, right? Well, a rotation is this complex object called a quaternion in Unity, and it's basically a 3x4 matrix, which is a really complicated mathematical concept, but we can basically set just as x and y and z rotation using float values, which is a much more intuitive way of understanding how this works. But they changed the functions on me, and I can never remember how it works, to be honest with you. Okay, what's the error it's saying? Cannot modify the return value because it's not a variable. Okay, so we can't edit Euler values. Is it Euler angles that we can edit? Returns or sets. There we go. Rotation. Cannot modify the return value of transform.rotation because it's not a variable. Max, you're in the chat. What am I doing wrong?
I don't really know.
Oh, sorry,
much
the other
about
Max.
the class, but...
Sorry, there's 2 Maxes in here.
Oh, sorry.
Say again, can you hear me?
Yeah, I can hear you. Trying to remember how to set the oh. You can just do Euler angles on the transform itself. You don't have to access it from rotation.
Right. Yep.
Okay, there we go. Now you can see. Hold on. It tries to update as the game is running, but it looks weird. So now if we start looking, you can see it's like resetting where it's at, right? So you can see it's like kind of rotating, right? But we're setting our transform equal to whatever axis is, whereas we want to add to it every time, right? Because if we move to the right a little bit, it'll add, 1 to the rotation. And then when we stop moving, it'll pretend as though it's 0, right? Because what the axis is the difference between our mouse movement this frame and last frame. So if we hit play again, and now if we move our mouse, boom, it works somewhat, right? Like I'm moving my mouse to the right and to the left. Well, if we move up and down, it doesn't do anything. So now what we need to do is we need to access the up and down of the mouse, which is the y-axis. So I'm going to hit, I'm just going to have my cursor at the end of this line. And if I hit Control D, it'll duplicate the line. And we're going to change this to mouse Y. And we're going to change this to mouse Y movement. And then we want to change, I can never remember which one it is. We'll go test it out and see if this is the right one. So now you can see if I move my mouse up, it goes down, and down, it goes up.
Oh, I hate inverted.
I think this axis will kind of rotate it as though we're a pilot doing a corkscrew. Let's try it. Yep. Isn't that funky? So you can see over on the left-hand side, do you see the circle that's rotating? basically pretending to be the rotation that we're doing. Okay, so all we want to do is, since it was inverted, we will move this guy back over to here, and we will just make this negative. And now if we hit play, and we move our mouse up, it looks up. If we move our mouse down, it looks down, right, and left. Okay, so of the code that we have just implemented, what doesn't make sense about this? Because I know I went over it quickly.
I think I got most of it. This is just theoretical for me because I couldn't keep flipping from one desktop to the other one, so I was just watching your one. But it kind of makes sense, yeah.
So, just to reiterate, this mouse X movement variable will be set somewhere between -1 and 1, right? So if we move our mouse to the right, it will be 1, right? Which basically means when we change our Euler angles, Euler meaning, or Euler, I guess is the correct pronunciation. Euler is basically the Cartesian coordinates in X, Y, and Z.
Okay.
So we're basically going to rotate him 1 degree on the y-axis if our x moves in the x-axis. And that may not make intuitive sense, right? Because on your mouse, right, left and right is the x-axis, right? Up and down is the y-axis. Whereas on the game object itself, the y-axis is rotating it like it's a spinning top, whereas the x-axis rotates it as if you're like looking your head up and down, right?
Oh, okay.
And then the z-axis rotates it as though you're like leaning your head to your left or leaning your head to your right.
Oh, fair enough. Oh, so is that because like the mouse, like on the computer screen, that's like a 2D plane,
Yeah,
and that's
so
what it's sort of understanding, and then the game world, it's 3D, so it can't get its head quite around it.
yeah, so it's basically having to transform the coordinate system from 2D to 3D is what it's having to do.
Okay.
And so what we do every frame is we just take whatever our current XYZ angles are, and we add whatever we've changed since last frame, right? So now I'm going to break this out into its own function to keep things really clear as to what's going on. So we're going to say update rotation, and then we're going to create another function. It's just going to be called, I'm not typing it out because I'm lazy, update rotation. And then we're just going to copy and paste all this code in there. So now what we want to do is we want to update the position as we move, right? So we're going to create a new function. We're going to call it update position. And we're going to go ahead and put our code in that function. I like to keep things super clean, so that way if Stefano, if for example you were just hopping into this project and you look at the update function, you don't want to see a bunch of code in the update function. You want to go see update rotation, update position, and go see how those individual things are working, right? It makes it more readable.
Yeah.
So when we update our position, every frame, all we want to do is just move in the direction we're facing. This game isn't working like normal Snake. We're kind of coming up with our own concept here, but it'll make sense here in just a second. So all we want to do is we want to take our game object, the one we're attached to, right? So when I say game object, that's similar to in Java saying, in Java and C# saying this, right? Basically the object that I am. We're going to access the transform of my game object. We're going to access his position. And we're going to add to his position whatever our current forward vector is. And this is going to be a little complicated. So we're going to say transform dot forward. And this is kind of a handy-dandy little function that Unity has inside of it. We can actually chop off game object here. So if I say transform, right, what that's referring to is, since I am this player movement script, I'm talking about the transform right here, the one that is attached to me, right? Which is kind of cool that you can access these things, right? And you have access to that transform because my player movement scripts implement mono behavior. Mono behavior has these things kind of handled for you, right? So all we want to do is when we update our position, every frame, we want to say our current position, which is an X, Y, and Z coordinate, move forward. And what forward is whatever direction our object is facing, right? So if I hover over forward, it says the blue axis of the transform in world space. So if I go look at my object, in this case, forward would be this way. But if I rotate him, forward would now be this way, right? And if I rotate him up, forward would be looking up, and so on, right? So now, if I hit start, you can see, oh, my object went outside the box, right? Like if I turn around, you can see I'm moving, right? Because I'm just going whatever way forward is. Does that make sense?
Yep.
Okay.
Yeah, sure. Can you debug log the vector, the forward vector, and stuff
Yeah.
like that?
Let's delete, start, and update debug logs, so that way we're not spamming it, right? And let's actually debug what the angle degree we're changing and the position, just to make it very abundantly clear what's going on. And that was a really good question, Max. Okay, so we're gonna say rotation, and we're going to add a plus symbol because that's how we concatenate strings. And we're going to basically print out the difference, right? Which is just this vector that we had. So we could make this a little bit cleaner and say vector 3 rotation change is maybe what a descriptive variable name would be. And we could set that equal to this guy. And now we could, instead of having to print this whole guy out, now we have access to that variable, right? Oh, we didn't put a semicolon. So now if we add a little bit of spacing, you can kind of see what's going on here. We access, I'll add some comments so that way when we upload this to GitHub and people access it later, there'll be comments. So access the current mouse input, this frame. Turn the mouse movement into a 3D rotation. Update my object's rotation with that new change. And then we're going to print out what that rotation change is. And then for position, we're going to debug.log. My forward vector, which is just transform.forward. So forward is a vector, right? A vector 3 is just means a three-dimensional vector, right? So it's a vector that has an x component, a y component, and a z component. Okay, so now if we go back, now you can see if I clear and we hit pause, so it's not outputting a bunch. If I scroll all the way back up to the top, you can see my rotation is 0, right? Because I haven't moved my mouse at all this frame. My forward vector is negative 0.1, 0.1, 1. If we go double click on my player, and that'll show us where he's at. If we look at his x and y rotation, he's just barely pointing off to the left, right? Which would be a little bit negative in the x, positive in the z, and almost 0 in the y. Because if we go look at him from the side, he's pointing up just a little bit, right? And basically we're moving this amount every frame, right? Which is just basically this blue vector that we see right here. That's the way we're moving every frame. So as we move, that blue vector points a different direction as we move our mouse, right? Does that make sense?
What if you make a really radical movement with the mouse? It still only does 1 or -1 per frame, right?
Let's go look.
Or does it do more?
Since this is happening 60 frames per second, we got to go scroll. It looks like the rotation can update the x and y in one frame. So you can see the x and the y are both changed. But since this is happening 60 frames per second, the majority of the time it'll only update one at a time, right? Unless you're moving your mouse really fast. All right, we on the same page? Does all that make sense?
Yeah, I think so.
Perfect. Okay, so now what we want to do is let's add a speed variable because I feel like we're going really fast. So we're not doing anything when we first start, so let's go ahead and delete that start function. And we're just going to add a float, and we'll call it player speed, and we'll set it to... Actually, we will keep that start function. And we won't set the player speed to anything up here. We'll set it in the start function. We'll say the player speed is equal to, let's set it to 0.1 to start. And we have to use the f to declare that it's a float. If we don't put the f, C# will complain and say it's assuming that the 0.1 is a double. If you put f, it basically casts that into a float, which are just a float is just less precise than a double. A float has 32 bits, a double has 64. So now, when we're updating our position, we want to multiply that vector by our speed, right? So if our speed is 0.1, it'll take this vector and basically make it 10% as long, which means we will move 10% less per frame. Does that make sense?
Yeah, sure.
If this is like a vector mathematics thing, right? If our vector is 1, 1, 1 in the x, y, and z, and if we multiply it by 0.1, all we do is we take each of these individual elements and multiply them by 0.1, so our resulting vector will be 0.1, 0.1, 0.1. So now if we go back and we play, you'll see our player should be moving much, much slower, right? It's much more manageable. And I think it still might be even a little too fast to start. So let's make it 0.05. So now it's half as fast. So if we're thinking hypothetically about how this game would work, maybe when we pick up food, all it does is increase your speed, and then when you hit a wall, you die. So maybe it's not like real Snake where like you have a tail that's attached to you. Maybe it's just you have to stay inside of this box and you have to keep eating food and you get faster and faster. We'll give that a try. So let's before we get to food, let's have it so that when you hit a wall, you reset, right? And basically it like resets your player. So how do we check if we've hit something? Well, our player doesn't really have a collider right now, right? It has no way to collide with things. So what we want to do is we want to add a component, and we're going to call it a box collider. So now if we go back to our player, it's not showing my box collider. Interesting. Okay, so what should be here is a light green box kind of showing you that we have a box around us that's 1 meter by 1 meter by 1 meter, right? 1 unit in Unity is 1 meter, or 3.5 feet. So yeah, we should have this green box. Oh, we turned off gizmos, that's why. Now we see our green box representing our collider, right? So if any one of these walls touches any one of these walls because they have a collider on them, Unity's physics engine knows that these things have collided, right? However, since we're just updating the position every frame, like Unity won't inherently prevent us from doing that, right? So what we need to do instead is use another component called a rigid body. So if we go to if we just type in rigid body, basically what a rigid body is it pretends as though it's a rigid 3D object. Pretend it's a pencil or a real 3D cube that is rigid, meaning that it's not fluid, right? A 3D object has a mass, a drag of the air, its angular drag, whether or not it should use gravity. In our case, we don't want it to use gravity because we're moving in whatever direction we're facing. Whether or not it's kinematic, meaning does it respond to physical forces? In our cases, it is not kinematic, meaning it does respond to physical forces. And then, collision detection, basically meaning discrete means it checks every frame. Continuous means it checks in between frames, right? So if my object is moving at 1,000,000 miles an hour towards this wall, right? Maybe one frame it's sitting right here, and one frame it's sitting on the opposite side of the wall. Well, the physics system wouldn't pick up on that if it was discrete. Whereas if you set it to continuous, it would check in between those frames using some complex math. So all we're gonna do is instead of just updating our transforms position, we have to tell the rigid body to move because the rigid body will respond to physics events. And it'll make more sense as we get to it here in just a second. But to tell our rigid body to move, we have to have access to it. And this is going to be an example of how getting a component on your object works, right? Default into mono behaviors, we have access to a transform, the transform that we're attached to, but we don't have access to the box collider or rigid body. So what we need to do is we need to get access to those. So we can grab a rigid body and we'll say my rigid body, I can think. And then when we first start, we want to get access to it. And the way we're going to do that is by using a built-in Unity method called getComponent. And getComponent basically says, I want to get a component attached to my game object. And then in these alligator brackets, you put the type of thing that you want to get, and that will be a rigid body. And it's a function that you call. So what this function does is it looks at my current game object. In this case, it would be the player game object, because that's what the player movement script is attached to. And it'll look at all of the components on it until it finds something named rigid body. And if it doesn't find something, it'll return null. But since we have something called we have a component rigid body, this my rigid body variable will be filled with a rigid body object, or a rigid body component that's attached to us. And what that allows us to do now is when we're updating our position, now what we want to do is we want to say my rigid body dot move. And what we want to do is we want to tell this rigid body to move. And we can tell it to move to a position. Or there should be, I know there's another way to do this. We could just add a force to it. Like pretend this is like, I don't know, a tennis ball and you hit it with a racket, and we just add force to it rather than moving it to a position. We'll use move position here just to keep things simple. And so the position that we want to move to is whatever our current position is plus where we want to move to, right? So we'll create a vector 3 called our new position that we want to move to. And that new position is going to be our current position plus the change in whatever we want to move between frames, right? So we could break this out even a little bit more, and we'll call this change in position. And we'll set that equal to this guy. Oh, this is a vector 2. We need to be a vector 3. Okay, so now we want to move to this new position. Okay, so what happens here? Every frame, we get where we're pointing forward, right? Which will just be a vector pointing from me to 1 unit ahead of me. We multiply that by whatever our speed is, so that way we make this not move as much. And the new position that we want to move to is wherever we currently are, plus whatever that change is, right? So if we go back to paint here, let's pretend that we'll use a green box to represent where we're at now, and we'll use this blue vector to represent where our forward is, right? So what we do is we take this forward vector and we multiply it by our speed. So now it's, this long, 10% of how long it was before, or 5% of how long it was before. And then we say our current position is here, and we want to add this vector to it, right? So now our green cube, after 1 frame, should move however long that vector is, so our new position would be here. Does that make sense?
Yeah, so you're just getting the difference between where you were last frame and the next frame, and then passing that to move position.
Yep.
Okay.
And the reason we're doing it this way is because the rigid body will interact with other colliders in the scene for us. Now we can no longer, if we go run this, we should no longer be able to phase through the walls like we did before. Like if I go walk into this corner over here, okay, we may be going a little too slow. If I go walk into this corner, boop, and I go back to my scene view, and I click on my player, you can see he's just kind of stuck in this wall, right? You see him kind of like jiggling a little bit. I can move him up, I can move him down, but he doesn't go into the wall anymore, right? Because our rigid body says, hey, dude, you hit something here. You're not allowed to pass through that because you guys collide, right? So now what we can do is we can check when we hit that wall, so now we know that the player has lost, right? And the way we do that is by another method that's built into a mono behavior called onCollisionEnter. And this is saying when we enter a collision, basically when my collider overlaps with yours. And so what we say is, if we entered something, let's just debug.log and say, you hit something, fool. I don't know. And let's get rid of the other debugs for now. We'll just comment them out so that we can turn them back on later if we have issues. And now we'll go check and see when we hit something, right? So if we clear out our console and we hit play, you can see our console should be clear when we start. And then when I go hit a wall, I should have moved up the speed for testing purposes. Boom. Now at the bottom you see, oh hey look, you hit something. But notice how it doesn't keep printing, because it's only when we enter the collision, right? It's only that first frame when it detects we're hitting something. Whereas if I look away and I come back to it, it'll print it out again. Oh, okay. You see how we're like kind of, I'm not moving anything. You see how we're kind of rotating? That's because when the rigid body collides with something, it tries to calculate the impact that you hit, so it applied a rotation to it, right? You see as I'm hitting the walls, it's kind of making me rotate. So what we want to do instead is we want to go to our rigid body, we want to add constraints to it, and freeze the rotation so it doesn't change our rotation for us. Because like you could think of like, if you're flipping a coin and the corner of the coin hits the table, it should add force to that corner of the coin and rotate the coin, right? The physics engine of Unity is trying to do that for us, but we don't want it to. We just want to know when we hit the wall. If I go hit play again, actually, I'm going to cheat. Our player speed variable, its default as private, but if we add public to it and we hit save, you can now see in our inspector over here the speed variable, and we can make it whatever we want. Let's just make it 2. That's way too fast. 0.2. If we hit play, now we should move much faster. We go hit our wall. Well, let me look over at us. And boom, now when we hit the wall, you can see where, if I, did we face through the wall? No. Oh, okay. So you can see how our camera is like way behind our object. You see our camera's like looking behind us in the scene view over here?
Yeah. It's like as
Yeah.
if we were following the player.
If I go look at the player, and if I look at the camera, you see how its Z is -10? So if I make the scene bigger, if I click on my player, you can see its position is here, whereas the camera is behind it. Well, Unity has this concept of local and world space. If my player doesn't have a parent, its position that I set here is in the world, whereas the camera has its parent, so its position is relative to its parent, right? So if I set these to 0, 0, you would think it would be 0, 0 in the world, but it's really 0, 0 relative to its parent, which is player, right? Does that make sense?
Yeah.
Cool. So all we had to do was reset the position of the main camera, and now it's inside of my player, right? So now things shouldn't behave as funky as before. Okay, so now we collide with walls. We know when we collided with walls. So what should we do when we collide with a wall? We should probably like respawn, right? So let's just for respawning, let's just say transform.position. We actually have to use the rigid body to move to somewhere, and we're just gonna move them back to the center to start, right? We'll just say a default function built in is vector 3.0, which is just if I hover over it, it represents 0, 0, 0. So we're saying, hey, you hit a wall, move back to 0, 0, 0. And let's go test how that works. And I will zoom my scene out here a little bit so we can kind of watch what happens. He hits a wall right about now. Okay, it didn't work, and the reason for that is a really good question because I have no idea. Maybe there's something that we're missing here about how the rigid body works. Okay, so here's what the problem is. In between each frame, we want to tell it to move to a new position, and when we collide with something, we're still going to be trying to update the position. So these things are going to kind of be overwriting each other, right? Because like maybe this guy hit the collision, but this guy was already in the middle of its calculation, right? And so like we stored the position that it was before, we move back to the center, and then this guy just says, yo, we're still pointing in the same direction. We still had it saved from previously, and we're just going to tell it to move to where we were before. So what we need to do is we need to turn off the rigid body, then move the position, then turn the rigid body back on so it doesn't know where it's at anymore. So we're going to say my rigid body dot enabled, I believe is what we want. Active. Interesting. I'm just kind of scrolling through the variables to see what all they have and see if I'm forgetting something. Feel free to ask questions as I'm poking around here. Okay, let's cheat. I did this before. If we go into my repositories, I have one called snick. If we go into their assets, scripts, we have player. Oh, so what I did is I set, we have this data called did lose, and I set that to true, and then I handled it in the update function instead. And then when I collided with something, I assumed that it was food, not the walls, and I destroyed the food, spawned new food, and then upped my movement speed. So instead of telling our rich body to move positions, let's say what we want to do is when we collide with something, we don't know if it's going to be food or if it's going to be a wall. So we need some way to check that, right? And you can see on collision enter comes with this thing called a collision. And if we go type in collision and we do dot to see what properties it has this property called other, or the other thing that we interacted with. I guess it's deprecated. So we can get the game object that we're colliding with. We want to do game object. And basically what we want to check is if it's a wall or if it's a food, and we haven't really done a way to we haven't really checked, or we haven't really set a way to determine what they are. But for now, we're going to say, we're going to add a tag. And if we go to Unity, objects can have a tag and they can have a layer, right? So for layers, you might have a layer for your UI, a layer for like your player, and you might have a layer for like the environment, like the things that you're going to interact with. And so basically what you do is you could turn on how different things interact with different layers, or you could tag them. The difference between tag would be layers you use more for ray casting. Tags you use more for checking what type of object it is. We can get into more examples of that in the future if that wasn't abundantly clear, because I don't feel like that was. So what we're going to do is we're just going to check for each one of these walls. We're just going to set its tag to, we're going to create a new tag. And if we go into tags, we hit the plus button. And our new tag is just going to be called wall. So if we go back to our cube, we select all of our cubes, and we set their tag to wall. And now we go back to here, and we say if the tag is equal to, tag is a string, and the string was wall. So basically say if the thing that we hit has a tag named wall, then we hit a wall, right? So we need to respawn. So we'll just create another function called respawn that we'll handle in a second. And then otherwise, if the thing that we hit had a tag of food, food is just what I'm calling the snake, the thing that the snake touches, then we'll call a function called eat food. So now we'll go implement these functions. So they don't give us errors. Okay, so when we respawn, or we'll rename this to be called lose, because we may not want to respawn. Maybe we want to have like a menu that displayed your score or something, right? So when we lose, what do we want to do? We want to have some sort of flag that checks for if we've lost. So we'll go back up here, and we'll create a boolean called did lose. And when we initially start, we want that boolean to be false, right? Because we didn't lose yet. But when we did lose, we would just want to set did lose to true. And then we'll handle how that works in just a second. In the update function, we'll just say if we did lose, reset our rotation and position. So say transform dot. Actually, we have to use our rigid body. My bad. And it's actually transformed at Euler angles. Okay, so if we lose, just reset, right? And also, something to think about, as we're going to eat food, what we're going to do is we're going to destroy whatever thing we got into contact with, and we're going to, let's say, multiply our speed times 2. So when we lose, we want to reset our speed to what it was at the beginning, which was just 0.05. That way, our speed, when we restart the game, we don't have that, increased speed again. Okay, so let's just go check and make sure that works. Watching our player. You see the camera moving. He hits the wall. He doesn't reset because we did something dumb. What did we do dumb? Okay, we can cheat here. We can turn is kinematic on, and then we can turn it off. And in between where we turn it on and off, we can just set our transformed up position. So basically, is kinematic is like checking for how these physics things should work. If we turn it on, it's basically saying, don't worry about physics, you do your own thing. So while we're in that state, we set our position and then we turn it back to working how it should. And that should work? Question mark? Boom, there you go. He reset. And now he's not moving for whatever reason. Okay. So why isn't he moving? Oh. Because every time we're updating, we just our did lose is still set to true, so it just keeps doing this, right? So now we need to set did lose equal to false. So let's break this out and say what should this function be called? Like handle loss. And we'll take all this out and we'll put it in a handle loss function. Boom. So now if we test it, I'm actually going to update the player's speed to be a little bit faster to start, so we don't have to wait as long. I'm looking around, I hit the wall, boom, I reset, and now I keep going. Okay. You guys have been really quiet. I feel like I've talked a lot. What do we want to explain how this works?
No, I think I kind of I've just been sort of trying to take notes and stuff, really. But you've set it to hit the. From what I kind of understand, it's going to be like kind of like a third-person 3D snake game.
Mm-hmm.
Okay, right. So the camera's just going to follow the snake, sort of over the shoulder, kind of thing.
We're just gonna pretend that we are the snake, like it's a first-person snake.
Oh, okay, right. Oh, fair enough.
Sorry if that wasn't clear.
Yeah, no, because I was sort of waiting for the where the fuck is the snake gonna be? But no, that's more clear now.
Okay, so now that we're resetting, now that we're moving, we're resetting. Now we have to worry about the snake part, and we can start by just eating food and increasing our speed, and then maybe we could figure out how to make a snake follow us. I haven't thought about how that would work in 2D. That'd be a fun little experiment for us to play with here. I'm completely down for that. But in the meantime, let's go ahead and figure out how we're going to deal with food, right? Let's just make food a cube, and we'll give that, we'll go make a new material called food, and I don't know, let's make it pink or something so it pops out. Boop, boop. And now we drag pink to it. And so now if we fly around in our scene, Let me make this bigger. Now we move around. We hit our food, and boom. We don't do anything with it, right? We just collide with it with our rigid body. So what do we need to do? Now we need to check if this food, remember we were going to give it the tag of food. So now that this guy has the tag of food, our function that we made earlier, that when we collide with something, if it has the tag of food, eat the food, right? So what do we want to do when we eat the food? We want to destroy that thing, right? Because we ate it, right? It should disappear and spawn a new one somewhere. So we need to pass that object that we collided with, right, into the eat food so that it can delete it. So we're going to pass in collision.gameObject, and so we need to edit the eat food, and we're going to call it food we collided with, and we're going to destroy the food we collided with, right? So we pass in that object so that we can destroy it, right? And maybe instead of destroying it, maybe we just want to move it to a new random location and up our score, right? So now we need some way to keep track of our player's score. So we have a public integer, and we'll just call it score. And we'll set our score to be equal to 0 when we start. And when we lose, we also want to reset our score, right? So we want our score to be 0 when we lose. But when we eat food, we want to, instead of destroying it, we can just randomly place our food that we collided with somewhere and then increase our score by 1. And now let's go implement this randomly place function. And so how do we want to randomly place it, right? We want to place it somewhere in between negative 20, 20, 20 and positive 20, 20, 20, right? Does that make sense?
Yeah.
Because these walls are 40 by 40, right? But they're at 0, so it goes 20 up and 20 down.
Yeah, okay.
So bottom left of the box is negative 20, 20, 20, and top left of the box is positive 20, 20, 20.
So you're giving it, like, the game world its coordinates.
Correct, yeah. So we're going to set its position.
Okay. Yeah.
So we're going to randomly place this thing, and we're going to say food we collide with dot transform dot position is going to be equal to a new vector. And what's that vector going to be? Somewhere between negative 20 and positive 20, right? So what we can do is we can say mathf dot random, math dot random. Random. Haha, random is built into Unity Engine, sorry. Dot range. So we want a range, and that range is going to be negative 20 to 20. And if you hover over the range function, it says between min inclusive, so it can be negative 20, and max exclusive, meaning it can't be 20, so it has to be less than 20. And they're integers, right? I think we want them to be floats, right? It's actually not a big deal. So, but you got to think our cube is 1 unit wide, right? So we actually want it to be 1 unit away from the wall. So let's make it negative 19 to negative 19. So that way it can't be inside of the wall, right? So we'll say int random x is equal to this range. And then we're going to do the same thing for y and z. So that way they're different random numbers. Whereas if we reuse this, it would be either 111, 222, whatever the random number is. And this would be a random z. So now we want to place it at this random x, random y, and random z, right? Because a vector 3 just takes in the x, y, and z coordinate, right? So we're setting our position equal to whatever this vector 3 is. So when we eat it, we randomly place it somewhere, we update our score, and we double our speed. Let's try it. Let's see if it works. So we have our food placed in here somewhere. It has the food tag. So now, if we go collide with it, it disappears. We move a little bit faster, it moves. We hit it, it disappears, it moves. And if we go click on our player, if I hit pause, you'll see our score is 0, so we did something wrong. What did we do wrong? We added 1 to our score when we ate the food. We randomly placed it. We doubled our speed.
Did we set a base score, or
I think we
did
set
we
it to 0.
display it?
We haven't displayed it anywhere. We're looking at it in the inspector. We can make a UI for it. Oh, okay. It's at 1. Maybe I hit a wall or something and reset. Where'd you get placed? Up here? Okay, you can see our score was up to 1, and then it went back to 0. If we go hit this guy, it goes up to 1, and our speed is upped. We go hit this guy. Cool. We can see our speed is doubling. Our score. Oh.
Whoa.
I think it thinks we're hitting the wall before we actually are. Is what it looks like to me.
Like how close to the wall do you have to like be before it resets?
Since we made our collider 1 unit by 1 unit by 1 unit, you have to be within 1 unit of the wall. And now you can see we're starting to pick up speed here.
Yeah.
Oh, and boom, I hit the wall and we reset.
Yeah.
Okay, cool. So it is working as
Okay.
we expect, right? So if I make this bigger and we I don't know, let's move ourselves to like the top of the box and look down into it. Let's kind of watch how this works. Okay, we hit a wall. We go down. And it is super slow to start. Hit this guy. Boom, we move. You can see our guy, the box teleport up here. We doubled our speed, increased our score. We hit this guy. We got to flick down instantly so we don't hit the wall.
Whoa, is that your stomach?
Max, was that you?
Oh yeah, sorry, yeah.
You hungry there,
thought
bud?
I thought I was muted to do that. I was going to say, how did you put the camera? The camera's still following the snake, but you're like zoomed out on the scene view.
Yeah, so the scene view is completely separate, right? It's like pretending it's a camera, right? Like the scene view is technically a camera, right? But this is me as like an innocent bystander, just kind of looking what's happening in the scene. Whereas the game view is like actually you playing it, right?
It's the one on the right, yeah.
Yeah. So if I go up to File, and then I hit Build and Run, let's make a new folder. We'll call it Builds, and we'll build to this folder. When this guy is done, it will run as though it's like an actual game that like you opened up on Steam and you hit play, right? So you'll see what the actual game looks like. Maybe this will help this sink in a little bit better. Oop, wrong button.
Yeah, no, sure. I think I understand it. It was more like you zoomed out, and I was wondering how you kind of did that in the scene view while the game was running.
The scene view is like unique to Unity, right?
Oh, so you can control the two like at the same time. They're kind of simultaneous.
Just it depends on which window you have highlighted, right? So like now that I built the game, right, you can see that it takes up my full screen, and it behaves as though I don't know where the box is. There it is. And now it behaves as though it's like an actual game that you'd play, right?
Oh yeah, sure. And the camera's fixed where it would be.
Yeah.
Yeah.
Yeah. Okay. Sweet. Yeah. No, I think I got it now.
Okay. So if I hit Alt F4, it'll close the game. But now if I like go back into my builds folder, the place that I built it to, you'll see I have this Snake 3D application, right? And if I double click on it, it'll run as though it's an actual game, right? Which is super cool. So the way that I like release Bunny Hop, right, is I have this application called Inno set up, and what it does is it basically creates a .exe, right? So if I go to Bunny Hop releases is where I store them when it's done, and it creates this executable file that when I double click on it, it pretends as though it's like a normal Windows installer, and it allows you to go through the steps to install it, right? And then when it's done, right, it'll create like a desktop icon, and it'll just be an application that runs. Okay, so before we get on to any other cool things, questions. Let's make sure everybody understands everything that's going on so far.
Yeah, I think I do. It's kind of like, I love it how the game gets really brutally hard, like really fast as well.
Do we want to make it less? Do we not want to multiply it by 2? Maybe multiply it by like 1.5?
Well, I don't know. Like if it's like a functioning game, like I don't know, maybe that's the fun of it. Also, just like play it in like stretches of 10 seconds where it just gets like really fast.
Or we can also make it. Sorry, go ahead.
It'd be kind of nice if like when you got a food, you decelerated like slightly, because at the moment it feels like you just hit the wall straight away. If you're going fast, you can't really turn fast enough.
And if it's too close to the wall as well, you could do kind of a bit fucked.
Okay, so let's do two things. Let's make it so that they can't spawn so close to the walls. Right, so let's just change this from -19 to, I don't know, -17 to 17. So they're always 3 units away from the wall to give you a little bit of a buffer period. And then, I don't know, we could have it increase your speed after a second or two rather than right away.
Yeah.
So the way that I would do something after a little bit, right? Like let's say I want to wait a second and then do something, I'm happy you brought this topic up because this is something that a lot of people probably have questions on. It's called a coroutine. And a coroutine basically says, I want to start this new process, and this process, like, basically, your game is running on one thread. Like, if you go to your task manager when the game is running, it's a process, right? And then basically what you're saying is, under this process, I want to start a new thread, or basically a new line of your processor handling things. And then he does whatever he does, and when he returns, we'll keep going, right? So what we're going to do is we're going to create a coroutine that after a second, it'll double the player speed. So the way you do that is you type start coroutine, and then you give it the name of the coroutine. And this is going to look really funky, but it'll make sense in just a second. Enumerator, and it'll be called update speed. And it doesn't know what an enumerator is. We have to import system.collections, because an enumerator comes from enumerable, which is basically something that can be iterated over, right? Like you can do a for loop over it. And an enumerator basically says it goes off and does its own thing and comes back, similar to how a for loop would, right? And so the name of the coroutine that we want to start is update speed. And I believe it needs to call it like it's a function. And so this guy says, we're returning an enumerator, and that doesn't quite make sense. But really, what you have to do is you have to do yield return something, right? You have to wait until you return something. In this case, null, right? So now you can see we don't have any more errors, right? So what we want to return is a new wait 4 seconds, which this is probably going to be mind blowing. So basically, what this does, you say, "Yo, go start this process." And he is going to return after a second, and then we can keep going, right? So if we update the player's speed after this function is called, right? This guy will basically pause right here for a second, and then we'll update the speed. Crazy, right?
Yeah, but it was easier than I expected, to be fair, with the built-in sort of
Yeah, I
stuff.
know, right? What we could have done is in the update loop, we could have put a boolean to basically say if waiting to update speed, do nothing, otherwise keep going. But the reason we wouldn't want to do that is because if we waited for 2 seconds, literally none of these things would happen. We wouldn't update our position or anything.
Yeah, is there any time that you'd want to do that over the coroutine, or?
If you don't know how coroutines work, that would probably be easier. But no, coroutines are great. Let's make sure it works first of all. So we're gonna click on our player, so that way we can watch him in the inspector to make sure the speed is updated correctly. And we'll play the game. And we'll see we start out at 0.1 with our score of 0. Where is it at? We eat our food, and the score instantly updates. Okay, did the speed instantly update? It did not. You see how it took a second to go to 0.4?
Nice.
Okay, I cannot find this cube. Where's it at? There it is. Haha. Now we're going painfully fast when we restart.
That's intense.
So what we could do, I don't know. Let's just get fun with this. This is the extent of what I had in mind. So now we can just start thinking of creative ways to make this better. Maybe when you hit something and it increases your speed, maybe it doubles the size of the area that you can play in.
Oh, okay.
Or maybe it doesn't increase your speed as fast, but maybe it adds your tail to you.
Yeah.
So
I like the idea of it getting bigger, because then it's also harder to find the cubes in.
yeah, we could also, as you get to higher levels, maybe we could spawn in some black colored cubes that are they're pretending to be walls, but they're just kind of floating in space. And as you get more food, there's more obstacles that you have to traverse.
Oh yeah.
Yeah, man, that'd be sweet. But I don't know how you keep track of your tail if it's in first person.
Me
Unless
either.
it's really long.
That
Yeah.
could be kind of hard, but it'd be fun anyway.
And so, and in 3D, right? Okay, let's think of how the tail would even work. Let's get really complicated about this. If the tail were, let's just say we create a new 3D object, a cube, and we move it behind it, right? As we do it, right? If we were to turn, the child would turn to be directly behind us as we turn, right? So we could never see our tail. So what we'd have to do is we'd have to attach it to its parent somehow that would allow it to rotate as we rotate, lag behind us. And so Unity actually has a thing for that, and it's called a joint, right? So think of it like, a bridge, right? Like the joint of a bridge. Like a hinge joint, right? Like a hinge. Or we could do a spring joint that, as you turn, it kind of jiggles, right? And so each of the tail pieces would have a joint with each other, right? So like a spring joint, like if this guy moves, this guy kind of jiggles behind it, right? And
Okay, like a sort of like a ragdoll following behind.
Yeah, let's pull the cube out and let's just attach some joints in between them and see what happens. Because I like to test things in small independent components. Okay, so we have 3 boxes. We're going to create a spring joint, and let's close some of these. Okay, so we have. Okay, spring joints have a lot of stuff. We have a connected rigid body. So I assume this is the thing that it's connected to. So let's click on this cube and drag him in, and it doesn't work. Okay, if we click on this guy, it'll open up things that we can connect to. So it looks like the things that we connect to are nothing. Okay, so that what we're gonna do, I don't know how this works. I haven't used it in forever. We're gonna go type in Unity spring joint, and it'll come up with the Unity manual, and it'll say, what is connected body? The rigid body object that the object with the spring joint is connected to. If no object is assigned, then the spring will be connected to a fixed point in space. I don't know. Let's hit play and see what happens. Oh, it behaves like a spring, right? You see these little orange dots? Right? This is the thing that it's connected to, and this is how it's like, it's pretending it's a spring being dropped up and down, right?
Okay.
So what we want to do is we make that connected anchor point one of these things back here, right? One of the other cubes. So what happens if we change this rigid body to... I wonder if we have to actually... Oh, auto configure... I see a checkbox. Should the Unity calculate the position of the connected anchor point automatically? No. Maybe now it'll let us choose one of the other ones? Hold on, maybe this guy has to have a spring joint too. I don't know. I'm figuring this stuff out with you guys. Okay, cool. So you see how I could click on the actual game object and drag him in, right? And in the connected body property, it has the rigid body. If I were to go double click on this, it would take me to cube, and it would basically highlight over this rigid body, right? Because when I dragged this cube in, it looked on this cube and saw if it had a rigid body attached to it and filled in that rigid body, right? So now if I hit start, this guy is attached to this guy, right? You can see this guy is jiggling based off of this guy. So now what we want to do is we want the first cube to be attached to our player, right? So let's say our cube is...
Sorry.
Go for it.
But the gravity is pulling down, right?
Yes.
So it's going to be like dangling, sort of like a keychain following you around.
Let's turn off the use gravity property on our rigid body and see what happens. So what I did is on the first cube, I set its connected body to my player. The second guy's connected body is set to the first guy, and let's go ahead and do it to the third guy as well, just to see what happens as we get more. We'll turn off gravity on him as well, and we'll set his connected body equal to the other cubes, right? So now if we hit play, I'm not going to move the player, I'm going to be looking at the scene. You can see the player is dragging them along.
Holy shit.
Okay, it looks all sorts of janky.
Wait, the player is the highlighted one, right?
The highlighted one is just one of the cubes. You can see the player is a little camera.
Oh, okay, right, yeah. Oh my god, that is nuts.
Okay, so I think this is a little too complicated. Let's do this. Let's up the damper of it, right? This is like how dampened it gets as things move. So let's up it. I believe it's between 0 and 1. So let's make it like 0.9, so it's like a really dampened spring, right? So like think of like a really stiff spring that gets dampened really, like the momentum of the pendulum gets dampened quicker. And let's see what happens. Let's zoom out here, and let's move our player. And if we look back, can we see our cubes? No, they turn way too quick. Whoa, we made a tornado.
Oh my god.
Okay. I'm getting really curious here. What happens if you just make a bunch of them and try and make like a tornado?
Yeah.
This is why I like game dev, because you can just do this stuff.
Well, like, what if you can you make the because I think they get quite far apart. Can you make the distance in between them not be like that great, like not that stretchy?
So we have a min distance and a max distance. I assume that's kind of what we're looking for, and then it has a tolerance. Let's go read the documentation and read into this. Okay, so we have the connected body, which is the rigid body that we're attached to. We have the point in the object's local space where the joint is attached. Local space meaning like, so the anchor point, right? If we go back to Unity, the point, so 0, 0 in this cube's local space would be the dead center of it, right? So you can see where the axes are. This would be so that would be 0, 0, right? So it looks like the connected anchor we want this to be set to 0 on all of them, so it's in the direct center of each of the things that it's connected to, right? Because right now it's at 0.5, which would basically be at the top of the cube. So this guy would basically be trying to be attached to the top of the cube. And actually, we want to connect it to the back of the cube, which would be negative 0.5 in the z-axis, right? So it should be, this guy should be attached to this guy right here, right?
Yeah.
So let's go change. I'm going to copy paste this because I'm a lazy programmer. And we don't want it to auto-configure. We don't want it to auto-configure. Okay, and let's go see what connected anchor is. The point in the connected object's local space at which the joint is attached. Let's in the player, we're going to toggle off the player movement script so the player isn't moving at all. So that way this is the point at which they're connected, and let's just see how they respond. Okay, so if we click on the player and we just drag him forward. What if we drag him up? So the player resets his position because he has a rigid body on him, right? So like the rigid body is trying to control how our player works. If we turn on his kinematic, they will no longer do that. So if we just move it, everything else will respond accordingly.
Nope. It's still a big. Oh, I love this.
This is actually super cool. Okay, so now if we watch them
It's
dampen,
just
let's
going
see how
everywhere.
they end up. Okay, I think we need to add some way more dampening so they don't do this crazy stuff. So let's go to each one of the cubes and let's shift click to highlight all of them, and then now we can
Yeah.
edit the properties of all of them. Let's just make the damper 0.9, and let me go read up on damper. Amount that the spring is reduced when active. Okay, and then we can update the strength of the spring because like this is how quick it would pull them to each other.
Yeah.
I assume. All right, let's just let's see how that works. Move it forward. Oh, moving forward. Not at all. What are you connected to? The player's rigid body. Oh, I was moving the camera, not the player.
Oh, okay.
So if we reset the camera. Okay, so now if we pull this guy forward. I need to turn his kinematic back on. Okay, so now if I move this guy.
Whee!
It dampens it way quicker. I still don't think it's quick enough. Hold on. What is this cube? Oh, this is our food. Let's rename this guy to food. So that way it doesn't confuse. We have to do it outside of play mode, otherwise it doesn't save. So we'll just call this guy food. And then, okay, so for each one of you guys, let's make the dampening like 0.99 and see if it dampens really quick. And let's lower the strength of the spring. Actually, I'm going to unpause and go to the player and turn on his kinematic when we start so we don't have to keep remembering to do that. Okay, now we'll move our camera here, and let's move our player. Okay, the strength is really weak, so it follows slowly. So I think we do want the strength to be kind of high, right? And we don't have to keep leaving the scene. Let's up the spring to 10, and they should pull each other back into place. No. What if I make the minimum distance 1, and now we move the player? Not working how we want at all, is it?
Honestly, it's kind of cool. I think I like how confusing it would be. Like if you suddenly have to turn the player and then just look back at this, it just freak you out.
Okay, I turned the strength way up, so it should pull them into place quicker.
I can kind of see the string in it.
I feel like they're moving. I feel like it's not dampening how I expect. I don't know. Let's go redo this.
What if we turn on the gravity just to see what happens?
I assume they're all gonna kind of like drop down. Yeah.
Yeah. Would they be more?
There we go. Now they're like
Oh yeah,
strung
now
together.
you can see the string. Yeah.
And it looks like they're attached correctly, right?
Yeah, yeah.
Okay. What else? Okay, let's up the angular drag to like 0.9. And let's up the regular drag to 0.9. So now they should have a lot more drag on them. So they're looks a little better. Okay, not particularly. What else can we do to play with this? Okay, so break torque and break force are like the amount of torque and force to break the spring, right? So like if we move too quick, like the connection between them could break, right? If it's not infinity.
Oh, for real?
Yeah, like this like basically tries to pretend to be a physical spring in life, like right? They tried to recreate that in code.
That's really cool.
Yeah, I tried to make spring joints by hand, and let me tell you, it's not fun. Okay, what is tolerance? If we just hover over it in Unity? No? No? Sometimes the tooltips that they give you in the documentation will show up in Unity if you just like hover over the variables, like for is kinematic, for example. I think I have to not be in play mode. Click back on the object. Yeah, see how it tells you the angular drag coefficient 0, blah blah blah. Okay, it does the same thing here. Okay, so damper can be between 0 and infinity. Oh, so we can up the damper way higher. So let's make it like 100. And let's make the string strength, let's keep it at 10 so it kind of sticks. Oh, we need to do it for all the objects. So we want this to be 10, this to be 100. Save. Now if we hit play. We move our player. Yeah, you see how hard it dampens the movement now?
Whoa.
Okay, I don't think we want it that dampened. We want it to have I feel like the connections aren't 100% right. This shouldn't. I don't know. Maybe it's because
Well,
like this guy's pulling on this guy and this guy's pulling him back. Maybe.
yeah, I think maybe like the
Yeah.
collision, because there's no gravity, so they're just sort of colliding and then bouncing off of each other.
Also, notice, see how they collide with my player? Like this
Yeah.
guy is sitting on top of him.
Hmm.
Okay, so what if we? Whoop, there we go. So if you pull him up, doesn't do a whole
Whoa.
lot. But if you pull him to the side. Okay, I think they're too dampened for how much strength it has. So let's make it 100.
Wait.
Okay, it might have been a little too high. Okay, so now if we jiggle the player. Hey, it's starting to look a little more realistic.
Yeah.
Still not like following in like a straight line behind him because we don't have gravity. Or because we have gravity.
Yeah.
You know what would be kind of cool? To make a visualization based off this, right? To basically have some center point and have it just start moving in a big circle and basically make a tornado of these.
Yeah.
I'm all for visualizations. Let's do it. So what we're going to do is we're just going to make a new scene.
I was thinking as well, like, because like if they're all the same, if because I don't know a lot about physics, but it takes weight into consideration. You can add weight to stuff, right?
Yeah, if we go
Like
if you go back to the,
theoretical
if we go
weight.
back to the scene, you can see the rigid body has a mass.
Yeah. Well, I don't need to do it now, but like just if it like if they're all the same weight, then they would sort of just go all around like as if they were in this sort of like a surface of a pool. But like if you make the one closest to the player heaviest and then decreasing the sort of the mass, maybe it would act like an actual tail.
That's a good idea. Hold on, let's okay,
Let's do the tornado thing first, just to see it.
I changed the mass. I'm trying to see how they behave now. I also upped the drag on them. It looks a little bit more realistic. I think the biggest problem is that they overshoot, right? We never want them to go past the player, right? We always want them to stay behind.
Yeah.
So I think instead of a spring joint, what we want is a hinge joint, right? So like basically like a tail, it can wag side to side, but it can't like go forward and backward, right? So you can tell it like on what axis the hinge is. But yeah, let's go play with this tornado. I'm curious.
Yeah, because that could be like an interesting thing as well. Like if stray from the snake motif.
Yeah.
Like the more of this you sort of the more food you eat, the more of this like shows up, and then eventually you turn a corner, there's going to be lots of like boxes just like flipping out all over it, so it'll be harder to find the actual food. Could be a cool mechanic.
Okay, so we're gonna get into another concept of Unity. So I'm gonna take this cube, I'm gonna call it a tornado piece. I'm gonna set its position rotation, and I'm gonna set its position rotation to 0. I'm gonna lower the scale, so we basically have like little particles of a tornado, right?
Okay.
And then we're gonna create what's called a prefab. So if we go and we create a new folder, we're gonna call it prefabs. And a prefab is basically a copy of an object, right? So if I click on this tornado piece and drag it, you can see down here it creates a copy of it, right? So now I can click and drag it back into the scene and make duplicates of it, right?
Okay.
So what we're going to do is we're actually going to delete this from the scene, and we're going to generate these prefabs at runtime, right? We're going to instantiate them, right? So we're going to go and we're going to make a new script, and we're going to call it tornado generator. We're going to open it up. If it's highlighted and you hit enter on it, it'll also open it up in Visual Studio. So what we want access to now is we want access to a game object, and we'll call it particle prefab. And the cool part about this is the inspector is one of the best I've ever seen in any game engine. If I go back to the tornado generator, the game object, and we drag this tornado generator script onto it, you can see we have this empty game object, right? Well, what do we want to put there? We want to put our prefab. So now, when the script starts up, like when we hit the start method, we have access to this because we set it before everything was set up, right? Like we basically set it in the scene, and now we have access to this particle prefab, which is pointed to this prefab, right?
Yeah.
So now when we start, what do we want to do? Let's just instantiate, I don't know, 5 of the prefabs and connect them together. So we're going to say we'll just do a for loop, right? We'll say starting at 0, going up to, we'll call it number of particles, and we'll create an integer called number of particles. That way it's easier to change in the future, and we'll just set it to 5. So we're saying we're starting at 0, we'll go up to 5, and we'll in between each one of those steps, we're going to step by 1, right? So this will go 0, 1, 2, 3, 4, and then it won't hit 5 because it's a less than. If I make it less than or equal to, it'll go up to 5. But we want 5 of them, so we're going to stop 1 less than 5 because 0, 1, 2, 3, 4 is 5 particles, right?
Okay.
Okay, so for each one of these, we want to do instantiate, which is another built-in Unity function. I can instantiate a game object. Well, what do I want to instantiate? This prefab. So I'm taking this blueprint of an object, and I want to create an instance of it, right? I want to create an actual physical copy of it. And this is why I kind of like teaching programming in Unity, because creating an instance in programming in like object-oriented may not make sense until you do it in 3D, because like I'm actually creating an instance or a copy of this thing in 3D, right? And this is actually going to return a copy of it. So we're going to say new particle. So once this is done creating that object, it's going to save it into this guy, and then we can do things with it. So let's go ahead and go back into Unity and just make sure that this guy works. If we hit start. If we look at the scene hierarchy, we have different clones of them, right? And we didn't set their positions or anything, so they're all set to 0, 0, 0. And like if I move one away, you'll see that they're all stacked on top of each other, right? And we created, in fact, 5 of them, right? If I move another, yeah, cool. We created 5, right? So now what we want to do is we want to connect each of the ones that we create to the next one that we make, right? So we want to say the new particle that we created. We want to add a component to it. Well, what component do we want to add to it? A spring joint. So now if I go back and I hit replay, come on Unity. If I stop and start, each one of these tornado pieces, now they have a spring joint attached to them, right? Because I added that in code, right? I created the object and then I added that component. It would be synonymous to me hitting add component and doing it right here, but I'm generating these at runtime, which is super cool, right? I don't have to set them up in the scene. I can do it at runtime.
Okay.
And you can see they all default attached to just some random point, right? But now we need to make them connected to each other. So what we need to do is we need to be able to have access to these things outside the for loop. So let's say we're going to have a public game object. We're going to have an array of them, and we're going to say particles. And so what we're going to do is we're going to go through each of these objects, and we're going to add a spring joint to them. And then we're going to add them to our particles. I like using lists better. They're a little bit easier of a data structure to work with, in my opinion. So when we start, we're going to make this, we're going to instantiate the list, And this may not make a ton of sense to you, Stefano, since you need to cover more of the basics of programming. But basically what this is saying is we're just going to have a list of objects, and we need to basically make room for it in memory. And then what we want to do is, now that we've created this object, we want to go to particles, and we want to add this new particle to our list of particles, right? Okay, so now all of our objects are created. They have the spring joint component on them, and we've added them to our list. So we're going to do this for loop again now that they're created. And basically we're going to say, we're going to start at 1, right? Because we don't want to do anything with the... Alright, bear with me here. We're gonna get a little complicated. Okay, we're going to say if I is equal to 0, if we're the first particle, we want to attach it to our tornado generator object, right? We want to say new, particles, and we want to get it at an index dot get component. I'll explain this in just a second. Bear with me. I believe it was connected anchor. Is that what it is? Connected body. That's what it is. Connected body is equal to get component rigid body. Okay, so what we're saying is for our first particle that we spawn, we're going to say our tornado generator is our object that we want to follow. So we want to add a box collider and a rigid body to him. And we're not going to have gravity. We're going to tell him how to move, right? We're not, like we did before with our player, we're going to give him input on how to move, right? So we could just say move him in a circle or something in code. So the first particle that we spawn, we want to be attached to our tornado generator. The second one, we want to be attached to the first one, and the third one, we want to be attached to the second one, and so on. Kind of like we're making a tail, right? So basically we're saying we're looping over this, and for the first one that we made, we want its connected body to be my rigid body. Otherwise, we're going to make this a little bit simpler. So what this line does is it says, hey, Mr. List that holds all my particles, get whatever I is equal to, right? So every time this for loop executes, I is going to be incremented, right? So it's when we hit this line, I is going to be equal to 0. We do everything, and we're going to come back up to the top, and I is going to be equal to 1, and so on until we hit whatever our max is, in this case 5, right? So this is saying whatever I is equal to, get that particle, and get its spring joint. If our I is equal to 0, set that spring joint's connected body to me. Otherwise, set that joint's connected body to the particle that was before it. Particles at I minus 1, so the one that was before it, dot get component rigid body. Ooh, I typed awful. Okay. Let's go see if she works. Actually, before I do that, does that make sense to you guys? I know the for loops may not be something that you're familiar with, Stefano.
Yeah, kind of. But again, I'm just taking notes here and following along.
Okay. If you have questions on it in the future, we can come back to it. But for those that do have that fundamental programming knowledge, that should make sense to you. Okay. So now we see they're just falling, and it's pulling my tornado generator down with it. So maybe if we turn on is kinematic, yeah, that's what we should have done. Our tornado generator should be is kinematic. We shouldn't allow the other things to impart force on our tornado generator. It should be the one controlling the force, right? So now if we hit play, our tornado generator is what these things are attached to, and you can see these guys are pulling each other down, but this guy is connected to the top one, right? Does that make sense?
Yeah, I see it.
Okay, cool. So let's take all their mass and lower them, and maybe that'll make it so that they're not so stretched apart. Oh, yep. Now they're moving super fast because the mass is so low.
Dang.
Nice.
Okay, so let's when we create them, we want to set their mass. When we create them, do they automatically? I think when we give it a spring joint, it creates a box. Actually, our prefab has a box collider. We also want it to have a rigid body. And we want to give its mass, I don't know, 0.5, give it a little bit of angular drag and a little bit of drag and angular drag. So now if we hit play. Boom, now they kind of fall on each other, right?
Yeah.
So now what we want to do is in code, move our tornado's center around, right? So if we were a tornado, let's have it like start at the bottom and kind of work its way up in a spiral, right? So if we're looking from the top down, we want to, in the X and Z axis, make it move in a circle. And then its Y axis, we just want it to move straight up, right? Does that make sense?
Mm-hmm.
Because that's how you make like a spiral going upwards. So in the update function, we want to say our transform dot position should be equal to it's X and Z are what we're doing in a circle, right? So we want to say mathf dot sine of, okay, this is going to be really weird to you. We're going to say time dot time. So this is going to be our current time in the game, right? And this is just some float, which this is basically saying this is how many milliseconds has passed since the game started, is what this variable is, right? And we're going to take the sine of that, so that way we're getting like a circle, right? And we're just gonna say we're gonna have some sort of variable to track our current y. We'll just make it public for now. We'll set it equal to 0, and then current y plus equal, and we'll just increase it by like, I don't know, 0.01 every frame. Oh, I forgot to give it a type. It's a float. And then we're gonna do cosine of current. Oh, that should be current time. Okay. So our position is going to be a vector 3, and that vector 3's x is going to be the sine of time, the z is going to be the cosine of time, and we're just going to keep increasing its y. Does that make sense mathematically?
Yeah, sure.
Mathematically, I'm just I'm more than I am at programming, so I'll take your word for
I
it.
think it'll be clear when you actually run the
Yeah.
game.
So
Yeah.
I'll just give you a little painting example here, because Trig's kind of a pain in the butt. If
Okay.
whatever our value is, in this case it's time, as time goes on, if we make a graph here, the sine of it will be this, the cosine of it will be, oh, I didn't change colors. The cosine of it will be this. So if we set the blue line equal to our x and our red line equal to our z, what should happen is we should make a circle as time goes on, right? Because this guy, if I just draw a circle here, make it blue. If we're at 0, our x is at 1 and our z is at 0. So 1 to the right, 0 up should be right here. If we're at time pi, then it should be on the opposite side. And then if we go all the way around, it'll come back. I hope that makes sense. That was a very crude drawing.
Actually, yeah, no, that really helped. Like as soon as I saw it, well,
Yeah.
yeah.
Okay.
So like then to make it sort of like a spiral, like a hurricane, like the z-axis would continually go up.
Y is up and down in Unity, but yeah, you can see it's spiraling in a
Oh,
circle,
but
and then it's
yeah,
also just constantly moving up, right?
yeah,
So you can see all of its children are following.
yeah.
So let's increase the speed at which it's doing this. So let's make its Y go up, I don't know, 0.5, and then let's make the camera a child of the tornado generator so it follows it as it goes up. And then we want to increase the speed at which it's doing this circle. So we'll just multiply this by 10 to make the circle bigger. More trig, I know, I'm sorry.
Right.
Okay, so the circle should be 10 units big, like its radius should be 10 units, and it should be moving up 5 centimeters per frame. Neural. You can see the okay. I think we need to make these guys a little bit bigger. I think they're a little too small. We'll move them back to 1 here. And it's kind of working how we expected.
Yay.
Okay, so step 1, all we have to do to make it bigger is we make this variable from 5 to 50, and now we spawn 50 cubes. And let's see how that looks. Probably actually insane. I did something wrong. I hard-coded something. From 0 to whatever this number is. Is this hard set in the editor? Hold on, let's make this private. I didn't hard code anything. Okay. That should work. There we go. We got a lot of cubes.
Holy moly.
Wow, it's like a necklace kind of moving around. That is sweet, yeah.
And I don't know. You want to like change the colors of the cube and make them look like a rainbow or something?
It'd be cool if we could add some like randomness to it.
Add some what?
Some like randomness, some noise, or
You want to let's pull these guys a little bit closer together. I think it's kind of a pain in the ass to see when they're so far apart. So I think what we can do is we can go to the spring joint that we created, and we can say joint dot what was it called? It was called spring for the strength of the spring force used to keep them together. Let's make it I don't know, 20. I don't know what a good value is. And then yeah, so to change, okay, I'm gonna see if that force made it look a little bit closer together. Yeah. Okay. Cool. They're following each other a little bit better now.
Yeah.
Okay. So now if we want to create color on our object, we have to edit the material, right? So let's go ahead and if we use one material and change the color of the material, it'll change it for all of them. We need a what's the easiest way to do this? We already have different colors, so what we'll do is we will just say public material. We'll just create an array of our materials, and then what we'll do is now in our tornado generator, since that's public, we can see our array of materials, and we can give it a size of 1, 2, 3, 4, 5, 6 materials, and then it'll give us the option. Now we can drag and drop them in. So our array now holds these materials. And now when we create the cubes, we'll just give them random colors. So we'll say, when we instantiate them, we will say new particle dot get component, and the component that we want to get would be the mesh renderer, because that's the thing that's doing the rendering. And if we want to do anything with it, we need a copy of it, and we'll call it my renderer. And then we want my renderer dot material to be equal to materials at some random number, and we'll just say random dot range, and we want it from 0 to however long our list is, which would be materials dot length. And let's see if it works. I can explain that in a sec. I just want to see if it works quick before I explain it wrong. Hey, we got some colored cubes.
wow.
Holy shit.
And this is one of my favorite things about Unity is just making cool visualizations. Like I almost want to just make like music visualizations or something, you know?
Yeah.
Yeah, it seems like it's kind of infinite stuff you could do.
Yeah. I still feel like it's spinning too slow and not big enough of a circle.
It doesn't look like a tornado.
Okay, so step 1 for a tornado. Not all pieces are independently quote unquote connected to each other, right? Like in a tornado, like it's more of a force applied to multiple of them, right?
Yeah.
And the force that would be, if I don't know, I'm just thinking about physics here. The force that would be some sort of downward spiral combined with an upward spiral, right?
Yes. Because the way I'm sort of like the way it is now, just like if you spin it really fast, it's just gonna happen that thing when you spin a chain like really fast, and it's creates this sort of sphere.
Okay, I'm a curious fellow. So what I kind of want to do is I want to, from each one of the children, I want to attach more off the side of it, maybe, so there's more objects to deal with, right? So like to one object there'd be like more chains attached to it.
Okay.
Okay, so we're going to get a little more complicated with our funky for loops. So when we create particles, instead of 50, let's make it 500. And we will have particles per chain. No. Hold on. For each one of these guys, we're going to set it being connected to the one before it. But on this guy, we want to create 50 new ones and attach it to him. So what we could do is we could do this exact same thing that we're doing here, but for each one of them, we just want it to be connected to the new particle that we just made. F. I don't know, we'll just give it some new variable name. And the connected body, we don't even want this. Actually, we either, if f is 0, we want it to be connected to not my rigid body, but the new particle's rigid body. And then we want it to be connected to the ones before it. That somewhat makes sense. Let's see if it works. I may have thought too quickly. I massively messed up somewhere. What'd I do? A joint can't connect a body to itself. And argument out of range exception. If we double click on an error, pause the editor. If we double click on an error, it should pull up in Visual Studio where that error was. Yeah. Okay, so this guy can't connect to itself. So if f is 0, joint would be the new particle. Oh, we didn't create anything new. Derp. We need to create the new particle. We need to set its renderer to something random. We need to add a spring joint to it. We'll call it new chained particle. My chain. I don't know. We're getting awful with the naming conventions here because I'm moving too quick. But so what this is gonna be doing is we're just gonna create another one, and we're gonna get the spring joint of the parent of it, and the for the first guy, the joint of the first guy should be connected to the parent. Every other one should be connected to the one that we made before it, and we didn't create an array to keep track of any of these things, so we're going to run into a problem there. Alright, we're getting too complicated with this. We're going back to what we were before. Okay, so if we break these out into functions, it'll get a lot easier, right? So let's say this guy would be connect chain to parent. And so instead of holding some global array of these particles, we'll pass them in. So we'll say game object particles, and we can get rid of this guy. And then, oh, where'd we break things? We actually don't want to add him to the list. Instead, we want to add things to him. So we want to say new particle dot, what was the name of our function? Connect chain to parent. I'm bad at this. I'm working way too quick. We still need our list of particles. Give me just a second to think about this, sorry.
Yeah, take your time, man.
Yeah, man, don't worry.
Okay, so I want this function that passes in some parent that they be connected to, and the chain of those things that should be connected, right? Actually, I don't want to pass in these lists because that's really memory intensive. So what we want to do is we just want to create this list when we come into this function. And we'll say create new chain. And so this function will return a list of these game objects for us. And this function is literally going to do what we were doing before. So we create a new chain by creating a list of particles. We instantiate all of them, we add it to the list, and then we return that list. So now we have access to a list of things. And the parent of the, okay, so we're getting this. Okay, so the parent that we're going to pass in the first time that we call this method is just going to be me, right? And we don't want to pass in a game object, we want to pass in a transform, because that's how things are going to be parented, so we can just say transform. Okay, so if I run this, things should behave exactly as expected before, right? We are going to connect a chain to a parent. The parent that we're connecting to it is ourself, or the transform generator. And we create a new chain of them, and then we attach them to the chain. Let's make sure that works. Cool. Okay, so now what we want to do is we want to connect a chain to a parent, and the thing that we want to connect it to is whatever the first particle in this chain was. So we almost need two separate methods. One to keep track of all the first chain. I don't know, what happens if we just do this a couple times? What happens if we just make 4 chains branched off of the parent? Do they all collide? Oh boy!
Whoa. What the hell?
That's
Oh, it's like a
so-
jellyfish.
It
Like
is like
kind
a
of
jellyfish.
tentacles or something. Yeah.
Okay, let's make it not 50. I feel like this is really process intensive. Let's lower
That
it
is
down to
insane.
like 15, and then let's just see how many times we can do it.
Holy moly.
Dude, this stuff is just so fun to mess around with.
Hey! Oh, what if you like
Oh, that's so
Oh
cool.
my
They all collide when
God.
they hit the middle. And now they follow each other because they all collided and stopped their momentum.
Oh my God. Can you go down like really quick?
Can I do what?
Just like make the object go oh no, wait. No, it's going up.
Hold on. I think I can I just set its position? No, I can't. Because it's being set at hold on. If I just pause this script, it's not moving anymore. Now I can just move it
Yeah.
however I want.
Oh.
Whoa!
Shit, dude.
Oh, there's your tornado.
Dude, this is probably the coolest thing I've ever made.
Yeah.
I like how each little grouping follows the parent, and then as it gets towards the end, it gets more chaotic.
Yeah. Are they the objects on the top like on a straight line, or is it just like clumped together?
So each one of these objects is connected to the parent, right? It looks like
Okay, yeah.
it looks like it's connected to something else. I don't quite understand why. Oh, like they should be like right at the bottom of this guy, right? Is it because I have a camera attached to it and it thinks no? I did something jankety. Oh. If I go to this guy and I change this to not auto-connected and 000. That's why, right? It should be it auto-configured the connected anchor, right? So it automatically thought that the position that it should connect to is over here. So what we need to do is turn that off and set it to 000. So let's do that. So for each one of the, you know what? It's fine. It's not a big deal. I think what we really need to do is just make the parent move quicker, right? And so we could get really complicated with it. that should increase the phase of the sine and cosine waves. It should just get going monumentally fast. Whoa, why is it sideways? That is so cool.
What?
Yeah, you see how fast my parent's moving?
Yeah.
Okay, maybe might be a little too fast. Actually, all right, we're getting more funky with it. What if we go to our prefabs and up the strength of our spring to be really high so it tries to follow that? Now things should get real physically intensive.
What the hell?
Okay, it's moving too fast. Instead of constantly increasing it, let's just increase the phase speed by 10. It's like a bunch of little worms like digging up to the surface of the earth.
Yeah.
So, because I'm a curious person, what happens? Okay, so when they first spawn, they're kind of spread out, right? Hold on, let's play and then hit stop immediately. Boom, hit stop. Okay, it spawned everything. They all spawn on top of each other, right? And then the springs kind of figure out how they should be working, right? So if I unpause, then they kind of separate into their disparate groups because the force on this guy is just minutely different than the force on the other guys.
Okay.
If we spawned them in a circle around them, maybe it would act more like a I don't know, pretend like an octopus is being spun, like its tentacles would actually like pull in the correct direction.
Hmm.
I don't know. I'm just experimenting at this point. If you guys want to do something else, I'm completely okay with that. I'm just having fun with it.
No, yeah, no, that looks lots of fun.
Okay, I'm gonna get more funky with it, and we're gonna move these guys back to being smaller particles, and we're just gonna make a lot. And then make this like, I don't know. Let's just see how Unity can handle this. This should make about 150 times 150. Oh my, this is gonna be like a couple million particles. It's gonna take a while to load up. Oh, and I crashed Unity.
Oh, good job.
Yep, GG, man. I was about to ask, like, what sort of overhead?
So the biggest overhead is instantiating a game object, right? Because it has to create the object, attach the transform to it, then it's attaching our spring to it, then it has to calculate the physics, and then every frame it has to calculate those physics. Yeah, we can reopen Unity here. That was might have gone a little overboard. Okay, let's make it like, I don't know, let's see if 30 is too much. There's a like a Unity profiler that we can go check how much memory is being used. Let's go poke around on that and see what happens.
Oh, yeah, I'm pretty interested to see. Is the profiler like a plugin or something?
No, it's built in Unity.
Oh, okay.
I think it's window rendering. Nope, general. Analysis. Profiler. Ha ha ha. So if I blow this guy up, you can see the CPU usage, the rendering usage, the memory, and the audio. So let's pull this guy. I can put this guy in its own window. Ha ha ha. Yes, I can. Okay. Let's lower this back down to like 20 and delete some of them to make sure it doesn't crash instantly on us. Okay, we know this should work. So if we hit start, let me watch the profiler. Oh, we don't need the game window. We're just using the scene window. Oh, we didn't open up the right scene. You see how when we open up Unity, it's on the untitled scene because it broke? So we have to go back to scenes and double click on our tornado scene. Okay,
What?
it's moving way too
Whoa.
fast. Let's just move it back to the way it was. And actually, I don't even want it to move at all. I'm just gonna keep it at 0, so it's just moving in a circle. Because I want my camera to just be able to watch it without having to move, you know? Okay. Oh, we're in the game scene. We want to be in the scene view. Okay, so just moving in a circle, and the lines are just following it. Okay, so now if we go look at our profiler, if we go look at our CPU usage, we're sitting at, on average, about 100 FPS. And then it dips. And I wonder if we can go look at why.
Oh.
Oh, we can scroll. Okay, so for rendering, you can see we're using most of it on batches, which is batching basically tries to say, hey, you guys all have the same material, we're going to put you into a batch and render you at the same time. Memory, we can see we're using about 230 megabytes, which is a lot. Materials is only using about 89 kilobytes. Meshes is using about 23, and textures is using about 27.
When do the dips occur? Like, what's causing that?
I have literally no idea.
Yeah, I was wondering that as well, actually.
I feel like we could almost put like debug points in our game and like stop it and see what's happening at that point in time. So I'm calling if we pause the tornado generator and don't make it move anymore, and we go back to our profiler, and these things start to steady out. I'm assuming the physics calculations get less over time. And they start to steady out, and we go up in frames, which it looks like it's the case depending on how much they're moving. Our memory hasn't really moved a whole lot. Why is it not moving anymore? It looks like you can like drag a line and look at everything at a certain point in time, which is pretty cool. What else can we look at? We can look at audio. Oh, physics. There we go. What other things would be spiking? The UI spikes for whatever reason, even though we're not using it. Oh, and then global illumination would be like the lighting calculations. Okay, let's turn off global illumination and see if it's trying to calculate lighting too fast, and maybe that's part of the problem. So if we go to our camera, and I believe lighting is in here. I thought global illumination is in here. Maybe it's on the prefab itself. No, sorry, it'd be on the material itself. So it has specular highlights and reflections. What if instead of standard for the... Okay, so on the material itself, you can use different shaders, right? And shaders basically tell the graphics card how to render the material that you've given it. So I'm wondering if you change to one without specular highlights or reflections. You see how the reflections go away on the material down here? Like if I turn back on reflections and specular highlights, it has like a light on it.
Yeah.
So I'm wondering if that lighting calculation is being part of the problem. Because it looks like it's using quite a bit of CPU usage, right? What's green? Total CPU. Red. Can we make this bigger? Oh. Oh, this shows you how much CPU time each thing is using. So the most usage would be input lighting. So lighting is using about 0.06 milliseconds, so like a millionth of 6 millionths of a second to calculate lighting. Whereas physics, it doesn't tell you how much actual resource usage physics itself is. I don't know, I'm assuming you could get much more detailed information about that, but I'm not sure I want to dig into that right now. But you guys know it's available for usage now.
Yeah. No, it looks cool.
All right, I feel like we've... Yeah, go for it.
Sorry.
No, go for it. What's up?
No, if you just make them all because they've all got lighting, right?
Yeah, I'm not sure. I'm assuming physics is the majority of the problem here. But if we go ahead and turn
Yeah.
off highlights and reflections, and we
Like
take
for all of them.
yeah, and then we don't use a metallic alpha, we just use albedo, and then lower the smoothness. And they're opaque because transparent is actually really expensive on a processor. Let's see what happens. If we go back to our profiler, it does look like okay, so we're broaching much more than 100 frames per second, unlike before. Right off the bat, right? Because like right off the bat, the physics calculations were too high, I assume, and it was making it dip too far. It doesn't look like it's made a massive difference, though, right?
Okay.
I assume physics is the majority of the problem here. That, and we just have so many game objects in the scene, right?
Yeah.
Like if I were to just go, delete how many chains we have and just have one chain of 50. Let's see what happens. It doesn't look like it's even running that much faster now, right? Like we're still hitting around 100 FPS.
Yeah.
And I don't think FPS is probably the way to measure right here, right? Because Unity is always going to try to get you to whatever the optimal FPS is. Apparently here it's 100.
Okay.
Okay, how about this? What if we lower the number of things in a chain to 1? We have one object spinning. Yeah, you see, we're still hitting about 100 FPS.
Yeah.
But our memory, if we drag a line here, we're still using about 200 megabytes. So it looks like Unity itself is just using a lot of memory, right?
Yeah.
So we're really only using about 30 megabytes of memory to store all the locations of them, right? Because it would just be 3 vector 3s for their location, the X, Y, Z or 3 floats for each one of the position, rotation, and scale, right? So we're storing 9 floats per object and having to update them every frame.
Okay.
I don't know. If we do a cursory calculation here, a float is 32 bits, which is 4 bytes. And if we have 3 of those per object, we're using 12 bytes. And if we instantiated, I think we had about, I would say 150. We had 15 chains and about 10 chains, so about 150 objects. So we're using about 1.8 kilobytes just storing their locations, not including any of their box collider information or rigid body information.
Hmm.
Anyways, I feel like we went off on a huge tangent.
We did. I just remembered that. Oh shit, we're snake game.
I also think this was more fun than it would have been otherwise.
Yeah.
I'm glad. I'm just thinking about all the cool things you could do to be there.
Yeah.
I like how we have our.
Like a solar system or something.
You could make a what?
Like a solar system with like different orbits and like planets.
I don't think you could do that with a spring joint. Oh, dude, I got a really good idea. All right, you guys want to try and replicate a solar system?
Please,
Fuck it, yeah.
I mean, I don't know if it can be done like.
I got an idea of how this would work. Okay, so what I'm thinking, right, is we have. Where's my paint? Okay, so we have I don't know, some object in the middle, right, and then we have some object with a spring joint attached to it, right?
Yeah.
And if we don't do anything and it has gravity, it's just going to try and fall, right?
Yeah.
Well, what if we turn off gravity and recalculate its gravity? Okay, so we give it some force going this way, we give it its gravity moving this way, and then we just keep this constant force moving this way and its gravity pulling in, right? Those are the two forces that make up gravity, or orbital systems, right?
Yeah.
And so what should happen?
So,
Sorry, go ahead.
no, yeah. So like eventually it makes sort of an ellipsis shape, just kind of not quite a circle, but just sort of going back and forth, like
Yeah.
kind of like a slingshotting.
All right, we're about to get super fun with this. Let's do. Okay, so now we have our solar system scene. We're going to create 2 spheres. One is going to be, I don't know, we'll make it 10 by 10 by 10, and we'll give it a yellow material to pretend to be the sun. And let's, I don't like the way this lighting is working. I just want it to be lit all the way. So we're going to change the material type to unlit, so there's no lighting on it. So now it's just yellow. Now you can't tell which way is which.
Hey.
Never mind. Okay, so we have yellow, and then, I don't know, we'll make a green one for Earth. And we'll make it 1 by 1 by 1. And we'll move it over here, and we'll make it green for the Earth. And then what we'll do, to start out, we will, I don't know, we'll just pull it way over here, and we'll give it force going forward, right? So, like, it'll travel along here, and then once it gets to a certain distance, gravity will start pulling it around, right?
Yeah.
Okay.
Can we, like, sorry, can
Yeah.
we make the gravity for this scene like an object? Can we give that to the sun?
So gravity is two-way, right? The Earth pulls on the sun, and the sun pulls on the Earth. So let's make an abstract class called, or an abstract object called gravity that has reference to the Earth and the sun, and that way it can kind of give those forces to each other, right?
Okay, yeah.
Okay, so we will, and we're not going to use rigid bodies or anything here. We're going to calculate this by hand and see what happens.
Fuck yeah, hardcore.
All right, so we will create a C# script, and we'll call it, I don't know, solar system. And then we will attach solar system to our gravity class. And then let's give these better names so that way I can figure out what they are. We'll call this one the sun, and we'll call this one Earth. Dude, this is super cool of like pretending of like how solar systems are formed. This may actually be really cool. Okay, so we go open our solar system, and what we want, if I can type, let's clear out all these extras. And we want a reference, a public game object reference to the Earth. And we want a public game object reference to the sun. And if we save this script and we go back to gravity, we drag in the sun to the sun, and we drag in the Earth to the Earth. So now we have access to them. And so what we're going to do is on the on update, all we're going to do is give the Earth force going forward, right? We're just going to constantly give it force going in whatever. I'm making them rigid bodies here, actually. So that way it can handle velocity for us. So all we're going to do, we're going to turn off gravity on both. We're simulating gravity here. We're going to give this guy a mass of 1,000, and we'll keep this guy's mass as 1. And what we're going to do here is we're going to say Earth.getComponent. We're going to get its rigid body. And we're going to want to duplicate these, and we're going to want to turn these into rigid bodies so we have access to them. Okay, so now we have access to the rigid bodies. So what we want to do right off the bat is we just want to say, actually, we don't want to get the rigid body every frame. We want to just do that in start. And then also at start, we just want to give Earth rigid body. Oh, actually, we didn't set their rigid bodies. We just got them. So now we have access to each of their rigid bodies, and they're set to something, right? So now we can say Earth's rigid body dot add force, and we're just going to add a force to it, right? Pretending this is like a universe simulation. And the force we're going to add is just a vector 3. And we just want to make it the forward vector of whatever way the Earth is pointing. So we're just going to say Earth dot, can we just do forward? No, it's going to be transform dot forward. Transform dot forward. Okay. What are you bitching about? Vector 3 does not contain a constructor that takes, we're not constructing a new vector 3. Forward is a vector 3. Okay, so when we start, what should happen is the Earth should just start moving forward. Okay, you see it's Z moving, it's just super slow. And then since it has angular drag, it dampens the velocity movement, I assume. It's moving just really slow. So let's multiply its forward by 10. So the forward vector is a unit vector, meaning the magnitude of that vector is 1. So now when we multiply it by 10, the magnitude of that vector will be 10. Okay, so now it's moving. I think it's still maybe a little too slow for simulation purposes. Let's just make it 50. And notice how every time I make a change, I'm kind of testing what happens.
Yeah.
Because I don't want to do a bunch of stuff and then come back and find out that, it was all worthless. Okay, so it's just going to constantly keep moving in this direction, right? Okay, so if we go up and look at gravity, I don't know, formula? I don't know the correct thing. It's going to be GMM over R squared, I believe. Gravitational pull formula. It should be GMM over R squared. Cool. All right, so okay, so what we're going to do is we're going to say apply force to sun and apply force to Earth. Actually, we can skip the sun for now. We'll do the Earth first, right? We're going to say we want to apply the force to the Earth from the sun, right? And so what we're going to do, I don't want to type that out, is we're going to say Earth dot add force.
I don't know about everyone else, but your audio kind of froze.
Not for me.
Try reconnecting.
Can you hear me?
Can you hear me now? I reconnected. Max, can you hear me?
Yeah, man. Yeah, definitely. I think you ended the stream, but yeah.
I ended the stream in Discord. Hold on, let me
I
reopen
suppose you had to, didn't you? If you.
Yeah, if I left the chat.
Of course, yeah.
Stefano, you may just want to reconnect. Discord freaks out after a while.
Yep, hang on.
I was wondering if there's a way you can kind of hot reload, like edit something, and then it takes effects like immediately.
Yeah, Unity's supposed to do that, but I don't trust it. Like, if I make changes and the app's running and I hit save in Visual Studio and keep playing,
Yeah.
I'm not sure what the constraints are, but things will break all the time, and I don't know what they are. So I just didn't mess with it, to be honest with you.
Okay,
I know it can, you just have to play with it.
Yeah, cool.
Okay, so what we need to simulate here is this function, right? And this is basically like the law of gravitation. And so we have a constant g, which is going to be 6 times 10 to the negative 11. Okay, actually, we're going to do this right. We're going to do this right. So we're going to say public float g is equal to... Oh, fuck, it can't be a float. It has to be a double because it needs to be super precise. Equals... Can I C# declare float with scientific notation? I'm curious if we can do this. Ooh, you can. So it's just going to be 6.674 e negative 11. Cool. So this represents, 0.0000001. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 6, 6, 7, 4. Right?
Yeah, it's the Euler number, right?
I don't remember what the name of it is. Gravitational constant.
Oh, I just meant like the E, but yeah.
Oh, yeah, cool. Yeah. E is not Euler's constant. It represents times 10 to the negative 11.
Sure, yeah, sure.
Okay, so this is going to be our gravitational constant. And so we want to pretend we want Earth's mass, and we want public double sun's mass. Okay. Mass of Earth. Oops. Which is going to be 5.972 e to the 20.
I love how there's like a specific number for that, yeah.
And the mass of the sun is 1.989. e to the 30.
We're getting like precise here.
Yeah, we are. I want to be as realistic as possible because maybe one of these constants is going to mess us up, you know?
Yeah.
Okay, so the force to apply is going to be the gravitational constant times the mass of Earth, Earth's mass, times the sun's mass, g mm over r squared. Yeah, mm over divided by the distance between them, right? So we want to get float distance, and we're going to say that's going to be Earth dot. There's got to be a distance function on vector 3. Distance. Yeah. Earth dot transform dot position and sun dot transform dot position. Okay, so now we have the distance between them. And since we have the what's our problem here? Gravitational constant's afloat, Earth's mass is a double. Okay, you need to be a double. Okay, and since math is, I don't remember if it's associative or commutative, we don't need to worry about parentheses because it's all multiplication and division. So the force that we want to apply is this force, but in what direction, right? And we want the direction of the from the Earth to the sun, right? And so to get the direction from one to the other, and we want vector 3 force direction to get. So I'm opening it up in Paint so I can remember how it works. If I have the vector for the sun, okay, yellow is not going to work. Vector for the sun is going to be black, and the sun's over here. Let's say it is I don't know, 5, 5, and our sun is, I don't know, 0, 2. The vector from here to here would be 5, 3. So we subtract the sun's vector from the Earth's vector. Yeah. Sun.transform.position minus Earth.transform.position. So we want to take the direction of the force, and we want this to be normalized, so it's a length of 1, and then multiply its length by the force to apply. Operator times cannot be used with vector 3 and double. It can only be used with float. Fuck. Fine. I'm assuming this isn't going to work because of the same stipulation. Can't convert from double to float. Alright, fine. Okay, so now we need the distance from Earth to the Sun in kilometers. 150 million. So... Okay, so to do this in Unity, fuck it, let's do it at scale.
Holy shit.
So we want the sun to be at the origin. And what is the radius of the sun? I wonder if Unity can even make it that big. Radius of the sun. In kilometers. 696,340. 696,340,000, because it's in kilometers. Okay, we are way inside of it, and I don't know if Unity can even go this big.
Can we zoom out like really far?
Well, let's just start flying and see how far we get away. Dude. Do, 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 do. And it speeds up as you zoom out. So let's see if we can even see outside the...
Oh, that's nice.
I know what's going on here. We need the far clipping plane to be like 1 billion. But we also need... Okay, so what I think we need to do is just divide everything by like 1 million, so that way we don't run into this crap. How about that? Like, just divide all the values by like some arbitrary number, so that way we're just scaling everything down, right?
Yeah, exactly. Yeah, it's still kind of relative. Yeah.
Yeah, let's do that instead. That seems much more feasible.
It would be cool if you could have it like to scale though.
By scaling it down, we're basically pretending that we are at scale, though, right?
Yeah, no, I didn't mean that. I meant if it was the actual value.
Got it. So let's take public double scale, and we'll set it to 1e to the negative 10. And what's the distance between? We don't need the radius of this. Actually, I'll write them all down so we have it. Public double suns radius is 696.96 e to the, if it's in meters, it's going to be 6. The distance from the Earth to the Sun is 150 million kilometers, which is 150 billion meters. Equals 1.5 e to the 1, 2, plus 9, so 11. We don't need the radius. Okay. So, if we make all these things somewhat realistic values, let's lower this guy to as much as we can. So if we make it negative 10, it'll be about 15 units away. So we're going to divide all the things by our scale. So we want the distance between them to be, let's make it 15. So you're going to be at 0, you're going to be at 0, 0, negative 15. Let's move you a bit over here. Okay, so we're going to apply force to you, always going forward. And the gravity that we're going to apply between the two of you is going to be, so if we take the mass times the mass divided by the distance, we need to divide each of the masses by our scale. Earth mass scaled is going to be Earth's mass divided by scale. And Sun mass scaled be Sun's mass divided by scale. So now if we use their scaled masses, and our distance is already pretending to be scaled, gravitational constant is constant, so it doesn't need to be scaled. So we had a force pointing in the direction. All right, let's see if it works, boys.
Does that mean it's working?
Considering there's a bunch of errors in the log, I'm gonna go with nah. Force assign attempt input force is outside of infinity. Okay. Okay, we're gonna cheat. And you're 6 more than you. Let's make you 1, and let's make you 7. There. Now force should be fine. It's going to be outside negative infinity because this guy is negative 11. Okay, we're pulling open the calculator, boys. We're going for it. Okay, so G is going to be, we don't want programmer, we want scientific. We want 6 to the, where are you at? Actually, we want E. Hold on, clear. We want 6 to the, That's not the right E. Y'all are about to make me break out my graphing calculator. Oh, X. Do you have E to the? No. Okay, alright, we're doing it in Paint, boys. That way it's visual. Actually, I want to type it out. I don't want to draw it out. I'll open up Microsoft Word. I've never used Excel. We can do calculations in Excel. I know, we're getting way off topic here. I'm sorry.
No, man, it's fun seeing, like, just where this fucking lead is. It's like, oh, let's make a snake game. It's like, oh, it's fucking solar system.
6e to the negative 11. Do you actually turn that into a number? Oh, you do. Perfect. Okay, so we got G, we got M1, M2, R. Mass 1 is 5e, we'll make it 6e to the 24. M2 is 2e to the 30. And what was the distance between them? 1 point, we'll just make it 2e to the 11. And we want, how do we do a function? I haven't done this in forever. I can just do this guy. This guy? How do I click? Anybody know how to use Excel? Oh, I did it. Okay. This G times this. Nope, that didn't work. You know what? We'll just copy and paste. This times this. Nope, you don't like it. Okay. G times MMM is going to be exponent of 54 minus 11, which is going to be 44, divided by 22. So we're going to have an exponent of the 22nd power for the amount of force that's going to be applied. If we divide everything by 10, then we should still have the same amount of force, right? Because this guy will be 14, this guy will be 20. Actually, hold on. If we scale each of them, the square of them actually will change. Fine. You know what? How about that? We just change the gravitational constant to be scaled as well. Still infinity. Fuck. So we take our distance between them, our Earth's mass divided by scale. Oh, it's already at. Alright. We got it. We manually scaled them. Alright, this should no longer be outside of infinity. God damn it. Alright, so you know what we're going to do? We're going to put in a breakpoint. We're going to run the breakpoint and see what the values that it's spitting out are. Okay, so you think the direction between them is 915, which sounds feasible. The force direction, okay, force to apply. Oh, to the positive 43. Because you're negative 11, you're 20 foot. Did I not comment them out? Yeah, you're 1 and 7. Did I not save? 5.97. Maybe I just didn't save. Round 2. Alright, I'm legitimately confused. Maybe it's because I didn't hit pause. For those of you who don't know what debugging means, basically I say, at this line, don't stop executing and let me observe what's going on in my program. Super duper useful. And it's not connecting for whatever reason. Okay, we'll attach to Unity. Basically, this like attaches to the process that is Unity, and then it waits for me to hit play. And then when it hits whatever my breakpoint is, boom, okay. Why do you still think I'm not? It like thinks I'm saved to this value. Fine, if we take off public. And try it again. I'm thinking what's happening is when variables are public, they can be set in the editor, right? And it's probably, yeah, it was storing what was saved in the editor. Okay, so now the force to apply is a little bit. Cool. All right, let's see what happens. I think we may have downscaled it a little too much. So it's basically just pulling it here. And it goes by it, and it hits it. Okay. And then it sends it out, and it should keep applying force to it, pulling it back in. As it gets too far away, the gravity is too low because the radius is too high, and it sent it too far out.
Kind of working though.
A little bit, yeah. Okay, so I think to make this a little bit more realistic, okay, so maybe we need to give it more velocity to start, so that way it doesn't hit the sun. So maybe make it like 100. Oh, you're still debugging. Guys, we did it. Okay, all right. It wasn't strong enough of a gravitational force. All right, so what we need to do is the gravitational constant isn't high enough, so let's, oh, it's -1. Okay, let's make it really high. Okay, if you guys have watched anything about like solar systems and how we can use space probes, this is actually really cool. Because what we do with space probes, right, is we send them near to the planets and they'll slingshot around them, right? Because it adds the force of our, yeah. Boom, and then it sends it off in a different direction, right?
Yeah, that was in, what was that fucking movie?
Interstellar?
From Mars. Also that one, but the Matt Damon one where he's on Mars. I think they both use it. It's like, oh, we don't have enough fuel, but then we have to like slingshot things.
But anyways, you know, our guy was going straight. We proved that we could apply force to him. Now it would just be playing with the numbers to get the gravity correct, right?
Yeah, just to get him back.
I feel
wait, is it coming back?
No, I don't think so.
Yeah.
Hold on. Let's Okay, hold on. Let me close out of some shit so I don't crash my computer.
I swear it was already sort of, because it was slowing down. And
We will output our current velocity as a variable. So let's just do public vector 3 current velocity. And every time we update, we'll just say our current velocity is equal to Earth's rigid body dot whatever its velocity is. There. So now we can observe what the velocity is as it updates. So over here on the right hand side, on gravity, we can watch its velocity. So you can see it's gaining a lot of speed in the x, losing some in the z, lost a lot in the x as it was being pulled back in, and now it's very slowly being pulled back in, right? And then once it gets super far away, it won't be decreasing very much, right?
Yeah. Oh, I can't tell if it's...
I know what I did wrong. I didn't multiply the distance between... I didn't square it.
Oh.
Because it's r squared. Because the function is g times m divided by r times r. Now it should behave. Now, basically, the farther it gets away, the less force they have on each other, right? But it's an inverse square relationship.
Hmm.
Okay, let's try this. Let's lower the size of the Earth so that they don't collide. Let's lower it to like, I don't know, 6. Let's make them get way closer together as he passes by.
Yeah. Is it going on a straight line?
It looks like it still is. I think it's just not coming close enough. Hold on. Let's just make you both the same size. And then let's make you come in at negative 2.5. So you should come in with 1.5. There we go. You should see it be very drastic here. Okay, I think our gravitational constant's too low. Or our mass is too low. Let's just make his mass like, I don't know, 4,000 times the size. Or 1,000 times as much.
Hey, so just unrelated. I was talking to Max, Walrus Max, like earlier today, and not on this stream because it'll be like way off topic. But one of the sort of ideas we're having, sort of like for games, kind of relies on a sort of... Oh, there we go. Oh yeah, there you did it.
Woo!
Oh, nice.
It works.
Damn, that's super cool.
What was I saying? Oh yeah. I'm wondering if like the next stream we could sort of maybe talk to you about it.
I mean, I'm not doing anything. What do you want to chat about?
Well, it's kind of like this idea for that sort of management thing I was telling you about. And Max actually broke it down like logically, sort of what like we would kind of need as well. Because it like the way I described it was like, oh, you probably you probably need to do this and this and this, and I was like, oh shit, that like putting it into sort of like logic terms was quite useful.
Yeah, I've kind of just thought like conceptually how it would work, but actually like putting it into practice might be somewhat different. But
Yeah.
I'm sorry, I'm just mesmerized by this that it's working.
No, it looks
yeah,
really
no, I'm pretty speechless myself.
Yeah.
Okay. Now I got more questions. What happens if I make some more Earths? That's too much work. Never mind. I take it back. But yeah, we can end the stream here. I feel like we had a lot of fun. I'm hoping you guys learned a lot, and then we can talk about your game off stream.
Yeah,
yeah,
sure.
that sounds good, man. Yeah, this was insane though. I wasn't expecting anything like this.
Yeah, this took a fucking turn, man.
This was not what I was expecting either, but this is just kind of where we went with it. Alrighty, thanks everybody for watching. I'm gonna end the stream here.